Hi everybody, extremely sorry that I'm a little late, but guess what? Actually, my iPad was not getting connected to the laptop. That is why I'm a little late. So I hope that you all are here with me. Extremely sorry, guys. Extremely sorry. Hello. Am I audible and visible? Yeah, I guess I am audible and visible, right? Alrighty then. I think let's start with the session. But just a minute, just a minute. Let me just get everything ready. Hi Manju, hello, very good evening guys. All right, so hello everybody. As I always say, Andiriki Namaskaram, Ellargu Swagatam. This is me, your master teacher Nabamita Bhattacharjee, and today we are here to start as well as end with this chapter that is called as S block. Yes, we are going to completely get done with S block today. Now, many students might ask that, ma'am, is it for NEET, ma'am, is it for JEE? But the channel name is JEE20, the channel name is Vedantu JEE English channel. So obviously, I am going to teach you mainly focusing on JEE. But yes, the syllabus is quite similar for JEE as well as NEET when it comes to inorganic chemistry. So if you are aiming for NEET, yes, of course, you can watch the session, no problem about it. But it will be a little bit more focused with JEE. I hope you understand that. Okay. All right. So shall we start with the session then? Are you all with me here? Are you all with me? Let's start with the session. What do you say? Yes. So let us begin with S block. Okay. Now, when we say S block, the first question that probably comes to your mind is that, ma'am, what are these S block elements, right? And like we have studied the P block elements, like how we have studied for D and F block elements, right? The very similarly, yeah, this is one shot. This is one shot. We will be finishing the whole chapter in just one go. Okay. All right. So when it comes to the definition, when it comes to the fact that we have to understand the definition, I'm guessing that you all already know how we define P block and how we define DNF block, right? Very similarly, we can write that exactly here as well. What do we say? We say that the last electron here enters into the outermost s orbital. Okay, the last electron enters s orbital, and that is why these are called as s block elements, right? These are called as s block element. Last electron enters s orbital, and these are called as s block elements. Now, in this s block elements, you will find only two groups. So, thank God. Unlike P block, where we had to read about group 13, 14, 15, 16, 17, 18, 6 groups we had to learn about. Here, we just have to learn about group 1 and group 2. Okay. Here, what do we have? We just have two groups. That is group 1, and we have to learn about the group 2. All right. These are the only two groups that we learn. Now, here what happens is s orbital, right? What did I write here? Last electron enters s orbital, bachus. So, if s orbital we are talking about, then tell me something. How many electrons can we fit into the s orbital? How many electrons can we fit into the s orbital? Everybody, yes, come on. Please tell me, how many electrons can you fit into the s orbital, everybody? Bachus, I am pretty sure that you all will be able to tell me that, ma'am, in s orbital, we fit 2 electrons maximum, isn't it? We can fit 2 electrons, right? So that means you can easily understand, or you can easily say that, oh, okay, so group 1 will probably have a maximum valency of +1, and group 2 will have a maximum valency of +2, and that exactly is the fact. Yes. So here what happens is, here you will see that the general electronic configuration is ns1, whereas in the group 2, the general electronic configuration that you will see would be ns2. Making sense, everybody? Till here, is this all clear? Till here, is this all clear, everybody? Yes? Is this all clear, guys? Till here? Okay. If that is clear, then let's move on and let's understand now that the S block has Group 1 and Group 2, and let's learn about the Group 1 and the Group 2 elements in detail, okay? Alright, so let me write that down. Everything that we study about is going to be in a tabular form. Yes, to be very honest, this chapter is very boring. This chapter is quite boring because there is nothing much that you want to do about it. At the end, you will learn about washing powder, Nirma, detergent powder, Nirma. Yes, that's it. Yes. And then you will talk about preparation of sodium chloride again, which is something that you already know, that sodium chloride is formed from evaporation of sea and everything. But yes, there are certain important questions like Portland cement and everything that also we are going to learn. And even last year, we saw that there were certain questions that were related to Portland cement. So everybody get ready with your notes. I want you all to make the running notes so that you don't have to come back later and say that, oh, Mom, I did not make any notes. Make it with me. I am also going to write it. I'm going to dictate it as well. So please start writing. Okay. Alright, so let's begin our journey with Group 1 elements. Yes, everybody? And do you know what these Group 1 elements are called as? What are these Group 1 elements called as? I'm pretty sure that you all know that these Group 1 elements, they are called as alkali metals, isn't it? What are they called as? They are called as alkali metals, isn't it? And here, if I write here Group 2 elements, what are these Group 2 elements called as? They are called as alkaline earth metals, right? They are called as alkaline earth metals. Now, if anybody has a NCERT book right in front of you, then in the NCERT book, you will find that when these elements, the Group 1 elements, that is lithium, sodium, potassium, rubidium, cesium, francium, yes, lithium, sodium, potassium, rubidium, cesium and francium, when they react with water, what do they form? They form hydroxides. And these hydroxides, my dear students, are actually very strongly alkaline in nature, hence the name alkali metals. Are you understanding? And I'm pretty sure that you all have common sense enough. So you would have understood that the Group 2 elements, when they react with water, they also form oxide and hydroxide. And these oxide and hydroxide are also strongly alkaline in nature and they are found on earth crust, which is why you see their name is alkaline earth metals. Am I clear? Am I clear, everybody? Now, if you remember that in the P block elements, we read about amphoteric oxides. Do you remember, everybody? Amphoteric oxides. And during amphoteric oxides, I had told you that how do you remember? You remember it as Punjabi song sang by Alia and Zoya. Yes, fetched Aishwarya crores. So Punjabi, that is PB, song, that is SN, sang, that is SB, by beryllium. Beryllium also forms amphoteric oxide. So my dear students, write it down that beryllium is actually not considered as an alkaline earth metals, but since it is present in Group 2, we do study about it in the Group 2 elements. However, it is not considered to be an alkaline earth metals. Are you getting my point? Just like in the DNF block, we read that zinc, cadmium and mercury, they are not transition elements, but they are DNF block elements. Am I right? Am I right, everybody? So very similarly, beryllium is not an alkaline earth metal, but yes, it is. It is a Group 2 elements for sure. Okay, it is a Group 2 element. So let's write it down, whatever I have told you. I have told you that on reaction or when it reacts, okay. What did I say right now? I just said that when it reacts, when reacts with water, forms hydroxide, okay, forms hydroxides which are strongly alkaline in nature, okay, which are strongly alkaline in nature. Am I clear, everybody? Yes. All right. And here, what did I say? Here I said that the oxides and the hydroxide of Group 2 elements are strongly alkaline in nature and found in Earth's crust. Okay. So let's write the same thing. Let's repeat the same thing here as well. When reaction, when on reaction, when it reacts, when the elements, let's write, yes. Let's make sure that our grammar is also right, isn't it? So when the elements react with water, react with water, they form oxides and hydroxides which are strongly alkaline, and are found on Earth's crust. Okay. All right, everybody. Do you all understand this? Great. Now, moving on from here, the next point that I said about the alkaline earth metal is that beryllium forms amphoteric oxide. Yes, beryllium forms amphoteric beryllium oxide, which is why this is not considered to be an alkaline earth metal. Okay. It is not alkaline earth metal. It is not alkaline earth metal. Are you getting my point, everybody? By chance, if you are confused and you are still thinking that, but ma'am, why? It belongs to the group 2 elements. Why are we not considering it to be a, alkaline earth metal? Because, hey, the oxide is not alkaline in nature. The oxide that is forming here is amphoteric in nature. So how can we change our rule and say that, na baba, na, this has to be, this has to be, alkaline earth metal. We cannot say that, right? We cannot say that. So that's exactly what I have written. Chalo. All right then. All right. Moving on, everybody. Moving on. Let's get back here. Yes. Now, what do we have to talk about? Let's talk about the general electronic configuration. Yes. Let's talk about the general electronic configuration. Yes. General electronic configuration, everybody. And what is going to be the general electronic configuration? I'm pretty sure that you would have guessed it, right? Yes, because we have done with P block, and I'm pretty sure that you all know how to write general electronic configuration. But here we go, everybody. Here we go. Okay. So what are the elements that are present with us? In the group 1, we have lithium, we have sodium, we have potassium, we have rubidium, we have cesium, and we have francium. Francium is definitely radioactive. Yes, and that is why you will see that, we will not be reading much about francium, okay? Because in your syllabus, radioactive elements are not to be spoken about much. Anyway, so how do we write the electronic configuration? If you remember, everybody, how do we write it? We write the noble gases first. So what are the noble gases? We have helium, that is Hina, Nina, arrived, Karina, Xeroxed, Ranbir, isn't it? Karina, Xeroxed, Ranbir. Correct? That is helium, neon, argon, krypton, xenon, and radon. And now what do we write? The general electronic configuration for this group is, everybody, the general electronic configuration for this group is NS1. Yes, NS1. So what do we write here? 2S1, 3S1, 4S1, 5S1, 6S1, and 7S1. All right? Yes, that is your answer. Cool. Now, moving on to the group 2 elements we have. In group 2, we have the general electronic configuration as NS2, everybody. Yes. And if it is NS2, then here you have all the elements, that is beryllium, magnesium, calcium, strontium, barium, and radium, right? Barium and radium. And this is also a radioactive element. Once again, very similarly, we will write the noble gases, everybody, that is Hina, Nina, then we have arrived. Yes, here we have arrived. Hina, Nina, arrived. Karina, Xeroxed. Karina, Xeroxed, and Xerox Ranbir, right? Yes, so what is going to be the general electronic configuration? Once again, everybody, very similarly, what do we write? We will write it as 2s2, 3s2, 4s2, 5s2, 6s2, and 7s2. So is the general electronic configuration clear for everybody? Right? Is the general electronic configuration clear, everybody? If it is clear, write down la 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 in the chat box. Now, we can clearly see that the oxidation state here would be, the oxidation state of the group 1 elements will be what? +1, right? +1 because you can clearly see that the moment they give away this one electron, they can easily attain the noble gas configuration. So the oxidation state is going to be +1, right? Now, if you want to ask me about valence electron, ma'am, how many valence electron are there? You can also clearly see that the valence electron is 1. That is, 1 electron is present in the last shell. 1 electron is present in the outermost shell of the elements, right? And they also form monovalent ion. What do they form? They form monovalent ion because they can be in the state of M+. M+ is their most stable state, right? M+ is their most stable state. And similarly, if I have to write it for the group 2 elements, what do I write here? Group 2 elements have an oxidation state of +2. Yes, what do they form? They form divalent because for them, divalent M+2 will be the most stable one, and they have a valence electron. How many valence electron do they have? They have valence electron 2, right? They have valence electron 2. Is this clear, everybody? Is this clear, everybody? And now, just like how we have studied in the P block, do you remember that the topmost element in their respective group will always show anomalous behavior, right? They will always show anomalous behavior. Why? Because small size, absence of d orbital, highly electronegative, and high ionization energy. So can we write that down here? I am writing it down here that anomalous behavior of what? Of beryllium and lithium. Why? The answer is that why do they show anomalous behavior? That's because of small size. Yes, because they are really small in they are very small in size, right? But guess what? They are only smaller in size when you compare it with the rest of the group. But if you try to compare them with the complete period, you will find that the group 1 and the group 2 elements are actually bigger in size. We will come to that. Okay? But they have small size, absence of d orbitals. Yes, absence of d orbital, right? Apart from that, what else is there? High electronegativity, high electronegativity, and they also have really high ionization energy. What do they have? They have a really high ionization energy as well. Am I clear, everybody? Yes, am I clear, guys? All right, everybody? Yes? Great, amazing. Now, let's talk about the atomic and the ionic radii. Yes, what are we going to talk about? Let us talk about the atomic and the ionic radii. What happens to the atomic and the ionic radii? What is the trend when it comes to atomic and ionic radii? Let's talk about that as well, okay? So, what do we have? We have here group 1. Let's write here group 1 and let's write here group 2. Yes. Yes, all right, everybody. Now you have to understand what did I just tell you? What did I just tell you? That they are group 1. Okay, this is something that we have learned in the periodic table. When we were learning about periodic table, we have learned that in the periodic table, the group 1 elements, they have the biggest size. In the periodic table, when you move from the left to right, you see that the size decreases, unless of course we're talking about noble gases. The noble gases, they are really huge in size, but except apart from the noble gases, you will see that the group 1 elements, they are much bigger in size, okay? They are much bigger in size. What do we write? We write that they are biggest in respective period, okay? Biggest in respective period. All right, and here we can write smaller than group 1, okay? What are they? They are smaller than group 1, everybody. They are also big. The group 2 elements are also big, but they are smaller than group 1. And just like how we already know that as you move down, as you go down in the group, what happens? Top to bottom, the atomic radii increases always. Why? Because you are adding on more and more number of shell. You are continuously adding more and more number of shell, more and more number of shell, more and more number of shell. So what happens here? We know that as you move down the group, the size increases, isn't it? So lithium, sodium, potassium, rubidium, cesium, and obviously francium will also have the biggest size, but francium we don't talk about it much because it's a radioactive element. Okay, all right. And when we come to group 2, in group 2 we see that beryllium, then we have magnesium, then we have calcium, then we have strontium, and then we have barium, and finally obviously radium as well. Am I clear, guys? Is this making sense? Is this making sense, everybody? All right, great. Okay. Then we come to, I will need more and more extra slides because I want to be able to write everything down and then teach you. I don't want to, the notes will obviously be there, the tabular form and everything is there, but I don't want to use that. What I'm going to do is, I'm going to write it down and explain it to you, and then you can obviously correlate it with the notes that are already written, just in case if you're not able to understand my handwriting, which I know is like a, my handwriting kind of looks like, I am, clicking mosquitoes and then sticking it on my paper, isn't it? So sorry. But please, I'm not an artist, I'm artistically handicapped. If you have been following me, then you know that my bulb looks like brinjal, and my brinjal looks like bulb, and my organic diagrams, they pretty much looks very bad. I mean, if I can draw a benzene ring properly, I think I will definitely go for a pat on my shoulder, and I'll be very proud of myself. Anyway, guys, moving on. Let's discuss. What do we have to discuss? Yeah, somebody is asking me, ma'am, answer bata do. Electronegativity सबसे ज़्यादा किसकी होती है? Who is this fellow? Yes, bacha, I have just told you that electronegativity will be the highest. Yes, electronegativity decreases down the group. So lithium and beryllium will have the highest electronegativity. Why? Because they will be able to, they are, the last electron is closer to the nucleus, smaller size, right? Smaller size. So that is why the electronegativity will be more in case of the first element. All right. Is this clear? Electronegativity always decreases down the group. Yes, decreases down the group. Clear hai? All right, everybody. Now we come to ionization energy. Yes. So what happens to ionization energy? Once again, everybody make the table. Yes, right here group 1 and right here group 2, everybody. Yes, so what happens in group 2? The group 2 will have group 1, first group 1, everybody. The group 1 will have the least amount of ionization energy in period. Do you know why? Because I just told you that they are really bigger in size, isn't it? And don't we know already, do we not know that ionization energy is inversely proportional to the size? That means if size increases, ionization energy decreases. So here what will happen is that they will have least ionization energy in a period. What did I say? Least ionization energy in a period. Okay. Least IE in a period. Okay. They will have more ionization energy than group 1. More IE than group 1. Okay. Then group 1. Am I clear? And how does the ionization energy differ when you come to the group? In case of a group, what happens? Ionization energy always decreases down the group. Why? Because the first element is the smaller in size, na baba. If it is smaller in size, then obviously ionization energy will be more. As you go down the group, the size increases. If the size increases, obviously ionization energy will be less. Yes. Yes, home decor, I have made a separate video, bacha. Please watch that. I don't know why you are constantly asking it here. Right now, I'm teaching. Focus up here instead of asking me about books. About the books, we have already made endless number of videos. Watch that and right now focus. Otherwise, in the book wala video, you will be like, ma'am, when will you do S block? Ma'am, when will you do S block? Ma'am, when will you do S block? Don't deviate. Now that I'm doing S block, focus up here. When I make the book video, that time you watch that video, okay? So, least ionization energy in a period, more ionization energy than group 1. And here what do we write? We know that as we go down the group, as we move down the group, down the group, IE decreases. Okay, IE decreases. So what can I write? I can write that lithium will have the highest ionization energy, then it will be sodium, then it will be potassium, then it will be rubidium, and then it will be cesium, and then we will have francium. Right, everybody? Great. And here also obviously pretty similar, because this is repetitive. Same thing we have to write here also. It will be beryllium first, then it will be magnesium, then it will be calcium, then it will be strontium, then it will be barium. Am I clear, guys? Is this understandable, everybody? Is this understandable? Great. Then we come across another property that is called as hydration energy. Hydration energy is something, or hydration enthalpy. Chahe you say, you can say anything you want. You can either say hydration energy or you can say hydration enthalpy. Both of them are same as almost. Although when you really want to know about the terms, you will understand that energy is a very vague term. Energy is a really huge term, right? Enthalpy is something that is like a smaller set in energy. All right. Yes. So let's talk about hydration enthalpy. What happens to the hydration enthalpy? What happens to the hydration enthalpy, my dear students? Hydration enthalpy of group 1 and group 2 we have to talk about. Okay. Hydration enthalpy of group 1 and group 2. So group 1 elements, everybody, what do we see that the group 1 elements do, and what do we see that the group 2 elements do? In case of group 2 elements, we will obviously see that as you go down the group, the hydration enthalpy is smaller. Why? Because as you have a smaller size, okay, if it is a smaller size, what happens is more number of water molecules, they come and they try to cover the atom. Yes, and that is why you will see that both lithium and beryllium, they have the highest hydration enthalpy. Why? Because in the group, they are the smallest atoms available, isn't it? So both lithium and beryllium, they have high hydration energy. They have high hydration energy. Now tell me something. I just told you that hydration enthalpy is also, what did I say? Is inversely proportional to size, right? What did I say? Hydration energy, that is hydration enthalpy, is also inversely proportional to size, and it is directly proportional to charge. Okay, it is directly proportional to charge and inversely proportional to size. Now I have just told you that group 1 elements in their respective period, they are the biggest in size. Group 2 elements are smaller. So you tell me, group 1 will have more hydration enthalpy or group 2 will have more hydration enthalpy? You guys tell me. Group 1 will have more hydration enthalpy or group 2? Till then, let me write down the trend. Okay, let me write down the trend. But you guys tell me in the chat box, what do you think it is? What do you think it is? Tell me, everybody. Yes. All right. And here we will have beryllium, magnesium, calcium, strontium, and barium. What do you think, guys? What do you think? The answer is, write down the note here. Write down the note here. The answer is that group 2 will have, group 2 will have, group 2 will have more hydration energy. Okay. Group 2 will have more, pagloos. What did I say? Size, inversely proportional to size, right? So group 2 elements are smaller. Group 2 elements are smaller. That means hydration enthalpy will increase, right? And I also told you that they are directly proportional to charge. So group 2 will have what? M plus 2, and this one will form what? M plus 1. So group 2 has more charge. If it has more charge, that means more hydration enthalpy. So group 2 will have more hydration energy than group 1. Clear? Then group 1. Clear? Hi Eob, how are you, bacha? Welcome to the session from Ethiopia. Love right back at you from India. All right, guys, is this clear, everybody? Is this clear till here? Any doubt whatsoever? Till here, any doubt whatsoever, everybody? Or are you guys understanding? Yes, any doubt? Any doubt? Let me know. Any doubt here? Any doubt here? Oh, by the way, hello friends, Chai Pilo. You have a doubt, Rishi? Rishi, you have a doubt? You have a doubt or you don't have a doubt? Quickly let me know. No doubt, na? Chalo. Okay. If that is the case, then next what do we have to do? Next we have to do, okay, these are done, see. All are silvery white, grayish white, harder than alkaline. Okay, so that means let's come to physical properties, okay. Let's come to physical properties, everybody. Chalo, physical properties. Very good. Purnima, I thought you just told me that you are here for the first time. I hope that you are liking the session, and don't forget to subscribe to the channel, because this is how we take class every single day. At around 4:30, I come live and I take a chapter, and then around 7 p.m. you will find my problem solving classes. Today I am taking JEE Advanced of P Block. Okay, I will do 5 questions in that session. So subscribe to the channel and keep coming back. Okay. Chalo. Now let's take a look at physical properties. What are the physical properties that we are going to talk about? We will be talking about melting point. We will be talking about how do they look like and blah, blah, blah. Okay. So first of all, let's go with our group 1. Yes. And I hope that you guys are writing down the notes, everybody. Please do make the notes so that just before your exam, you don't have to run around here and there for your notes. Okay. You should not be running around for the notes. You should be able to make it on your own. Okay. So we have just seen that group 1 elements. Do you know how they look like? Have you seen sodium? Have you ever seen sodium? How sodium looks like? If you haven't seen, sodium actually has a silvery white color. Okay. Sodium has a silvery white color. Okay. So let's write it here. Silvery white color. And you all know that sodium is a very soft metal. And so is potassium. Don't you know that you can actually slice sodium and potassium with a knife? Don't you know that? Yeah. So silvery white, right? Next, we can write that they are very soft metal. I mean, they are so soft. They are so soft that sometimes you feel like, chee, thoo, you are a metal or what? You actually feel like it. Like, thoo, you're not even a metal. You feel like saying that. Like, like, what a weirdo. What a weirdo. I mean, we all know that metals are supposed to be like hard and, you should be the incredible Hulk to be able to break it down. But look at sodium, like, why are you even a metal? Right? Why are you even a metal? But anyway, they are metals, what to do, right? They are also shiny. Okay, see, now there are 2 properties. There is one property that is the fact that they are soft, which is not matching with the metal property. But look at it. We all know that metals are lustrous, isn't it? And they are also, my dear student, lustrous. That means they are shiny in nature. What are they? They are shiny in nature. Now, when we come to group 2, in group 2, we know that they are grayish white in nature. What is the color? They are grayish white in nature. These are also soft but harder than the group 1. Okay. These are harder than group 1 elements, and these are also shiny. So, lustrous. Acha, tell me something. Do you know that why do they have such soft nature towards themselves? Do you know why? Because metallic bond, usually the hardness is attributed to the metallic bond. That means the stronger is the metallic bond, the harder will be the metal. So if you talk about iron, if you talk about scandium, titanium, vanadium, the D and F block elements, they are almost all of them are metals, isn't it? And you will see that when we studied D and F block elements, I kept telling you that they show variable oxidation state. Do you remember that manganese could show +7 oxidation state? That means that 7 electrons it can give away to the sea of atoms. Okay. What does it do? It gives away 7 electrons to the sea of atoms, and that means that the bond is strong. There are 7 electrons that can form a bond, and that is why the bond is very strong. But here, the group 1 and the group 2 elements, only one electron or 2 electron they will form, right? They will give, right? Only 1 electron, with the help of 1 electron, they will form a metallic bond. Or with the help of 2 electrons, they will form a metallic bond. It's not enough. It's not enough for them to be hard metals, right? And that is why we see that the group 2 elements are slightly harder than the group 1 elements, but they are also soft, okay? They are also soft, okay? All right? Yes. Okay, somebody in the chat box is asking, ma'am, diamond is metal or non-metal? Ayyo. Don't give me a heart attack, bacha. Diamond is an allotrope of carbon, which we studied yesterday. We have studied about diamond in carbon family. Carbon is a non-metal. No, which class do you belong to? Please don't tell me you are appearing for JEE now. Please don't tell me. If you're appearing for JEE and if you do not know if diamond is a metal or a non-metal, it is going to be disastrous. Anyway, all right. So we have understood this. We have understood how do they look like. Yes, is this clear, guys? Is this clear, everybody? Great. Now, moving on from here, let us talk about their mass. Okay, what happens to the mass? What happens to the mass? We all know as you go down the group, what happens is the mass increases, right? As you go down the group, the mass increases. Now, do you know that mass, what is directly related to mass? Density. So, if mass increases, density increases, mass increases, density increases, because these both are directly proportional to each other. What is the formula? Don't we know the formula? The formula is density is equal to mass by volume. So, mass increases, density also increases, isn't it? Mass increases, density also increases. So what happens to the density in this case? The alkali metals, they are really huge in the size, isn't it? And therefore, what happens? Now you have to understand that mass increases down the group, the mass increases, no doubt about it. But also, they are the largest in their respective period. Such a large size, that means volume is high. Volume is high. So what is happening? Volume is high. Now the mass and the volume becomes the deciding factor here. What happens? The volume becomes the deciding factor here. So the volume is really high. Density reduces. Density reduces. So what can I write? I can write that alkali metals are bigger in size and that is why less density. Less density due to big size, okay, due to big size. Am I clear, everybody? Are you guys understanding? Less density due to big size. Do we understand this? And here what will happen? Here what will happen? More density than the alkali metals, obviously. Yes, more density than group 1. More density than group 1. Am I clear, everybody? This is clear, guys. Is this clear? Now we come to melting point. Okay. Now we come to melting point. Now, melting point, I was just talking to you about the metallic bonding, right? And I just told you that, you know how iron or manganese, they have really good metallic bonding. So, do you know something that the melting point is always directly proportional to the number of valence electrons? Yes, the number of valence electrons. Yes, and it is directly proportional to the metallic bonding. And it is directly proportional to the metallic bonding. So that means we can understand that the group 1 has only one valence electron and the group 2 has only two valence electrons. So what can I say? I can definitely say that the group 2 has more melting point than group 1, right? Group 2 has more melting point than group 1. Am I clear? The group 1 has least melting point. The group 1 has least melting point. Okay. Group 1 has low melting point. Am I clear, everybody? Is this understood? Okay. Is this understood, guys? Is this understood? This is all clear? Great. Now what happens is, okay, from here a question may definitely come, and this topic is, everybody, flame test. Okay, what is this topic? The topic is flame test. You must have a look at it because this is very important, and from here a question may be there in your JEE mains especially. Okay. All right. Now, what happens is, if you remember coordination compound and the DNF block elements, right? In the coordination compound and in the DNF block elements, we have spoken a lot about how color is attributed to the excitation of electrons. Do you remember? Yes. Do you remember, everybody? That color is always attributed to the DD transition. That is what we studied in D block elements. Now, obviously, here we do not have D orbital. But do you understand that one electron, that NS1, that one electron in the outermost shell, that has a tendency to excite. that has a tendency to jump, that has a tendency to excite itself. Why? Because it is loosely bonded. It is away from the electron, it is away from the nucleus, it is loosely bonded, so it has a tendency to excite itself, and which is why you get to see some colors. Now these colors are very important, okay? These colors are very important, everybody, so please note it down, please note it down, okay? Do not miss out on this. So chalo, let's write it down. First of all, what do you have? Li. Now Li, everybody, is Li is in the color of crimson red. Do you know how I remember? Do you know how I remember? This is actually my favorite lipstick, okay? This is actually my favorite lipstick, everybody. This is called as Lakme, and the shade is, I don't know if you can see it, but the shade is crimson silk, and it is red in color. And it is red in color. Everyone, I can show it to you. This is red in color. See, this is red in color. So this is how I remember Lakme, Li, Lakme, Li. And what is my favorite shade of lipstick? My favorite shade of lipstick is, write it down, crimson red. Okay, Lakme crimson red. My favorite lipstick, all time favorite. Even right now I'm wearing that only. Even right now I'm wearing that. Okay. All right, everybody, will you remember it? Ma'am has showed you her favorite lipstick, everybody. Lakme crimson red. Okay, this is how you remember the first color. Then what do you know? Then you know that sodium, S for sodium, S for sun. Sun is what color? Sun is golden yellow in color, isn't it? Sun is golden yellow in color. So write down golden yellow. All right. Now what do you have? You have potassium. Now ma'am belongs to which school? I belong to Kendriya Vidyalaya. So Kendriya Vidyalaya, K for potassium and V for violet. V for violet. Now that you know these three, so this is absolutely my class. Group 1, see, this is what happens when you have a narcissistic teacher. So much self-obsession, everybody. Today you will see Nabamita Ma'am's self-obsession. What did I tell you? What is my favorite lipstick? Lakme crimson red. Okay. Then what is it? S for C. Na. So Na is Nabamita. Na is Nabamita. And you also must know that one of my favorite color is yellow. One of my favorite color is yellow. Trust me, guys. If you don't believe it, I can show it to you. See, I also have a wallet that is yellow in color. I have a wallet that is yellow in color. Not even kidding. I don't know if you have seen anybody who has yellow color wallet. Yeah. So yellow is one of my favorite colors. So sodium, Nabamita, golden yellow. Then Nabamita Ma'am has studied. I have done my schooling class 1 to 12. I have completed it from Kendriya Vidyalayas, everybody. I have been in Kendriya Vidyalaya Itanagar. I have been in Kendriya Vidyalaya Guwahati, Khanapara. So yes, KV. So K for potassium and V for violet. Once you are done with this, now you come to rubidium. What is rubidium? Now that you have written violet, what do you write? You write red violet. Rubidium, R for red, and you write RB, so red violet. Okay. Then what do you have? Then you have cesium, C. The moment you say C is what? Blue in color, so you write blue. That's it, done. Will this be will you all be able to remember this, everybody? Let me move aside and please tell me, will you all be able to remember this or not? This is your flame test. Very easy. This is your flame test, everybody. Okay. All right, everyone. Chalo. Moving on now. Now, what do we have? Now we have beryllium here. You know what? Beryllium is a smaller size than lithium, isn't it? Beryllium has smaller size than lithium, and so does magnesium. Magnesium and beryllium, they're small in size, and they do not show the flame test. What do? They do not show flame test. Okay, do not show flame test. Do not show flame test. All right, everybody. Cool. Now we have C. Now we have Ca, calcium. Ca. You all know how do you go from one place to another? You take a cab, right? So Cab, that is brick red. Write down brick red. Okay. Yes. Now, how do you remember? Usually in Hindi. Okay. See, again, I have studied from a Hindi medium school, guys. I have studied throughout my life. I have been in Kendriya Vidyalaya. So obviously Hindi is next to my mother tongue. Although my mother tongue is Bengali, but you know what? Hindi is a stronger language of mine than Bengali. I mean, I probably cannot write in Bengali, but I can read and write in Hindi. Hindi is basically like my first language. But anyway, so in Hindi, we used to learn this group 2 elements as beta mange car, scooter, baap razi or baap roye, right? You know, beta mange is like the son asks for car and scooter, and the father cries. That's how we used to remember it. So, you know how I said that cab here? Yes, can you all remember it? Cab, calcium, brick red. Then you have scooter here. Strontium is scooter. So scooter, and then what do you have? Scooter and car can we write? So crimson. This is also crimson red. Okay. All right. SR crimson. All right. Or SRC. SRC you probably all remember, isn't it? What is SRC? Because Baap has to shell out money, no. The father has to shell out money from the pocket, right? Obviously, the father will cry, isn't it? And then you have BA, bag, bag. You can remember BA. So, barium, apple, green. Barium, apple, green. So, what do we know? We know that cab, scooter, car, bag. Cab, scooter, car, bag. Can you remember this? Calcium, brick red, strontium, crimson and bag. That is barium, apple, green. Is this clear, everybody? This is your flame test. Okay. This is your flame test. And by the way, also learn, just write this down. Okay. Why does this happen? Because of electrons excitement. Okay. Electron excites. Electron excites. Okay. That is why it happens. And these are oxidizing flame. Just know this, okay? These are oxidizing flame. What are they called as? These are called as oxidizing flame. Just write this. Not more than that is there in your NCERT. So I think that's it. It is enough, okay? Okay? All right, everybody. Yes, are we done with this? Now we come to chemical properties. Everybody, are you all ready with chemical properties, guys? Let us start with... Thank you, Shivesh. Thank you. But I'm not so intelligent also. If I was so intelligent, then I would probably have a Nobel Prize, or maybe I would have been doing my PhD or postdoctorate. But you never know. There is always a chance for that. Just kidding. I'm not going anywhere. Anyway, guys, moving on. Chemical reactivity. Everybody ready? All right. Yes. So the first thing that you have to write is, now let's study about the group 1 elements. Okay. Let us study about the group 1 elements. These alkali metals, actually tell me, bachos, we all know that when you have a bigger size, right? When you have a bigger size, obviously what will happen is that the electrons are a little far away, isn't it? The electrons are a little far away from the nucleus. So what will happen? The electrons can participate very easily in the reactions, isn't it? The electrons can participate very easily in the reaction. So what will happen? They will be reactive. They will be more reactive. So the alkali metals are highly reactive in nature. Can we write that? Alkali metals are highly reactive in nature. Highly reactive in nature. All right, everybody. Yes, all right. Now what happens? In the group, you see that lithium, sodium, potassium, rubidium and cesium. Lithium is the most reactive, okay? Lithium is the most reactive one. So it is lithium, sodium, then potassium, then rubidium, and then you have cesium. This is the trend in the group, okay? Now when we come to group 2 elements, in the group 2 element, what happens is, Namita, I'm not doing, that's why, no. I'll make sure that you complete your JEE mains and everything, and then maybe, yes, take a lecture in ionic equilibrium. Yes, bacha, coming up. Today we will complete S block, right? Please make a list of all the chapters that I have completed. Till now, what are the ones that we have completed till now? No, what is left? Let's count, because completion, so we have done a lot, right? What is left is, we are left with thermodynamics. Thermodynamics is coming on this Saturday. This Saturday, you will see one shot of thermodynamics. Then we have chemical equilibrium, then we have ionic equilibrium, and then we have metallurgy, surface chemistry, environmental, biomolecules, right? And one last thing that is left is P block, group, nitrogen 2, No, P block, oxygen to noble gases, that is also left, right? Yes, these are the only thing that is left, isn't it? These are the only chapter that is left, and we have anyway started organic. So with organic, side by side, we will keep continuing those as well, okay? Side by side, we will keep continuing this as well. Ma'am, at what time will be the one shot? This is a one shot. This is a one shot. Ha, bacha, some of my previous lectures are there in the channel only. You can check it out, okay? Yeah, okay. This is a one shot. Angel, this is a one shot. Are you asking about the thermodynamics? The thermodynamics one shot will also come around 4 p.m. only. I think I will upload it at 4 p.m. Okay? I will upload it at 4 p.m. only. Chalo guys, group 2 now. Group 2, what do we have? The alkaline earth metals. They're slightly less reactive than group 1. Okay? Group 2 elements, group 2 elements, group 2 elements are slightly less reactive than group 1. Less reactive than group 1. Okay? Alright? But you just write it down that every day around 4:30 I will take a concept video like this. A chapter video, one shot chapter video will always happen at 4:30, and 7 p.m. I do a problem solving class. Okay? 7 p.m. I'll be doing a problem solving class. So every day from Monday to Saturday 4 p.m. there will be a chapter class. Okay? Just write it down. This is my normal timetable. This is my normal timetable. So here what will happen? Here what is the trend? Same. Just write that down here also. Beryllium will be most reactive obviously. Then it will be magnesium. Then it will be calcium. Then it will be strontium. Then it will be strontium. And then finally you will have barium. Alright. Yes, this is the trend. Cool. Alrighty. Acha. Now what do we have to learn about? Now let's learn about... one second. I need more pages. Because I'm going to write everything down. Chalo, guys. What did I do? Oh, it's all there. It's all here. Ha. Next, what do we have? Next, we have reactivity towards air. Okay, what do we have? We have reactivity towards air. Chalo. Reactivity towards air. All right, let's do this. Now, in air, you have oxygen as well as nitrogen. These are the abundant elements in the air, isn't it? These are the most abundant gases in the air. What are the most abundant gases? Again, you have learnt about it, oxygen and nitrogen. And you also know how to separate oxygen and nitrogen, fractional distillation. We have read about it in the P block elements, isn't it? So, let's get back to everybody. First one is your group 1. Let's talk about group 1 here. And here, this side, we have group 2, everybody, okay? So, what happens is that the group 1 elements, okay? So, the metal plus dry air. When I say dry air, that means that only O2, okay? Dry air, only O2 will form what? Oxide, obviously. Oxide it will form, right? Now, if you take the oxide and if you mix it with moisture, then what happens? Then you will get a hydroxide. But this oxide is also different. I have always taught you, everybody, you know, when Pratik sir teaches you or when Shimon sir used to teach you, right? Shimon sir, everybody knows Shimon sir, isn't it? So whenever Shimon sir teaches you mathematics or when Pratik sir teaches you, what do you do? And if they give you an amazing trick, what do you say? OP sir, OP. You write that, no? OP. This is exactly what happens here. Here also the oxides that are formed are like that. You get oxide, peroxide and superoxide. What do you get? You get oxide, peroxide and superoxide. So let's check it out, everybody. Okay, let's check it out here. Okay. What do you get? The first thing first, let's write it down. You have lithium here, then you have sodium here, then you have potassium, you have rubidium and you have cesium, isn't it? So what will happen is this lithium, when it reacts with dry air, it will form oxide, Li2O. What does it form? It forms oxide, my bachus, okay? It forms oxide, my dear bachus, okay? Then when sodium reacts with oxygen, sodium forms a peroxide, that is Na2O2. It forms peroxide, okay, bachus? All right. Then rubidium, cesium and potassium, what do they form? They form superoxide. What does it form? KO2, RbO2 and you get CSO2. Yes, what are these? These are your superoxide. These are your superoxide. So can you remember OP, sir? OPS, oxide, peroxide, superoxide, oxide, peroxide, superoxide. Now this oxide that you see, this oxide will have an oxidation state of O minus 2. The oxygen will be in O minus 2. In the peroxide, the oxygen will be in minus 1. And in the superoxide, the oxygen will be in minus half state. Okay? Minus half state. Hey, neat biology. Bacha, I am tired of telling you the syllabus again and again. Bacha, the syllabus that is removed is from your NCERT CBSE board. The syllabus has not been cut down. Nothing has been removed by NTA for JEE main. So if you are a JEE aspirant, you have to study it. And if you are only aiming for 75% criteria in your board exam, then you might not have to study it, but otherwise you have to study. So please forget about this thing that, oh, syllabus has been removed, syllabus has been reduced. The syllabus has only been reduced for your board exam, not by NTA. NTA makes your JEE question paper, not NCERT. So study. Okay. I'm not teaching you here. You know what? Syllabus has been reduced. I can also take a holiday and go to Goa and sit. Na? Why do you think I'm passing my time here by teaching you? Rather, I can take an afternoon nap and sleep and like this I can get up. Huh? Why am I teaching you? Why am I teaching you? Not just like that, na? Telugu. I only know Cheppandi and Chayandi. These are the only two words I know. That is what Rama ma'am has taught me. KRD ma'am has only taught me this much, but I should go and meet her for the next part of the session. Anyway, guys, come back. Acha, now what did I tell you? I told you just now that you get oxide here. But do you know that some amount, okay, just a little bit amount, when this lithium is reacting with oxygen, it not only forms oxide, but it also forms a little amount of peroxide. What does it form? It forms Li2O2. Some amount, only some amount of peroxide is also formed. All right. And then when you come to peroxide, sodium peroxide, with sodium peroxide, you will see that some amount of sodium superoxide is also formed, just some amount, very trace amount, okay? Very trace amount. It's not too much. It's not too much. Okay, is this clear, everybody? Is this clear, guys? This is clear. Now tell me something. These are all metals. All the group 1 elements are what? Metals. And metallic oxides are usually what in nature? Ah, you know it. You know it. I only used to teach you in the lower grades also, isn't it? Yes, so everybody, I know very well that you know that these are basic in nature. What are these? These are basic in nature. Metallic oxides are basic in nature. And non-metallic oxides are acidic in nature. Don't we know about this? We do know about this. Chalo. Now coming to the group 2 elements, everybody. In the group 2 elements, what do we see? We see that because of beryllium and magnesium, right? Beryllium and magnesium, if you try and make them react with air or plus water, you will see that they will not give you any reaction, okay? They will not give you any reaction. However, if you take the powdered form, okay? Powdered form if you take. So these are the people, you know, there are some people who won't listen to your sweet conversation. You will have to you will have to properly beat them up to make them listen, right? Not beat them up. Beating is a wrong word. You will have to scold them a little bit. So beryllium and magnesium also, you'll be like, react, no. They'll be like, no. React, no. No. And then what you have to do is you have to take them and cut, powder them. Then they will be like, okay, reacting, chill. Then they will react. So what happens? If you take powdered beryllium and if you take powdered magnesium, then definitely they will react with oxygen. They will react with oxygen and they will give you BeO, MgO. Alright, they will give you beryllium oxide and magnesium oxide, but only when they are powdered. Makes sense or nonsense, everybody? Great, clear? Alright, okay. Now, what about this calcium? What about calcium? What about strontium? What about barium? Yes, they all react with oxygen. And what do they give you? They give you oxide. In this case, they only give you an oxide. Okay. In this case, they give you oxide. So you will get CaO, you will get SRO, you will get BaO. Acha, why are they giving you? Why are they giving you CaO, SRO, and BaO? I mean, come on, guys. You know what is the oxidation state of O2? 2. What is the oxidation state of this group? 2. Group 2 elements will show +2 oxidation, and oxygen also shows oxidation state of 2. So what will happen? Cancel out. Cancel out. So what will happen? CaO, SRO, BaO, BAO. Right? And of course, we know that since these are also metallic in nature, except beryllium, yes, rest all are basic in nature. So let's write that down. Except beryllium, rest are basic in nature. Rest are basic in nature. Make sense or nonsense, everybody? Is this clear, guys? Is this clear? Is this clear? All right. Now what are we going to do? Now let's take a look at reaction with nitrogen. Shall we? Reaction with nitrogen, because nitrogen is also a part of air, isn't it? Nitrogen is also a part of air. So let's write down about nitrogen, everybody. Yes. How do you think that the group 1 and the group 2, they will react? Okay. Remember I told you sometime back only that lithium and beryllium, they have what? Lithium and beryllium, they show anomalous behavior. And you will actually get to see this anomalous behavior right here, because you notice that it's only lithium which reacts with nitrogen and gives you a nitride. What does it give you? It gives you Li3N. Okay, it gives you Li3N, which is nothing but lithium nitride. Okay, it forms lithium nitride, but rest of the elements are sodium. Yes, then you have potassium, then you have rubidium, then you have cesium. These do not react with nitrogen. There will be no reaction. Absolutely, my dear students. Is this clear, everybody? Great. Now, what about this side? This side, you will see that they do react. Once again, beryllium and magnesium, they will only react in the powdered form. Okay, they will react in the powdered form. So, Be plus N2 will give you what? Be3N2. All right. Same way, Mg will also form Mg3N2. All right. The same way, you will have calcium. Calcium will also form Ca3N2. Am I right? Then you will have strontium will also form Sr3N2. Am I right? Then you will have barium. Barium will also form Ba3N2. Clear hai? Oh my God, so much of writing work I have to do. N2, N2 and N. Ayyo. This will be N2 plus N2. Chill. All chill? All cool? Everybody understanding? Yeah, this is cool? Okay, so here we are ending the reaction with air part. Okay, reaction is air part is done. Then what do we do? Let's do reaction with water. Okay, let's do reaction with water. How do we do reaction with water? Again, very simple, very easy, everybody. Chalo, let's take a look at reaction with air is done. Then we do reaction with water, because we know that air and water are vital elements. Right? So reaction with water. Jal hi jeevan hai, pani hi jeevan hai. They say no. So jal hi jeevan, and we know that oxygen is anyway jeevan. So let's do this. Reaction with water, once again, everybody, 2 groups. Let's divide it. Yeah. So what will we get? We all know that Li plus H2O. What will you get? Acha bachus, sometime back only we have read now. This will form what? Li will form Li plus. It will form a monovalent ion. Monovalent ion. It can give away 1 electron and it can form monovalent ion, isn't it? So that means you can clearly say that it will form LiOH plus there will be obviously LiOH. See, it's not balanced. There are 2 hydrogen atoms here, right? 2 hydrogens. So this will be H2 gas will evaporate. Yes. H2 gas will evaporate. Hi Yash, I'm good, bacha. How are you? And also you can clearly see that this will be plus, this will be minus. Right? Okay. Similarly, then we have sodium, and sodium, so I don't have to teach you. No? Sodium, everybody knows. Sodium, potassium, rubidium, cesium and Francium, though we don't have to study because francium is radioactive. Nobody talks about radioactive, okay? These, when they react with H2O, what will you get? What will you get? You will get NaOH plus hydrogen gas. Yes, you will get potassium hydroxide plus hydrogen gas. You will get rubidium hydroxide plus H2 gas. You will get cesium hydroxide plus H2 gas. Clear hai? Is this something that I even have to teach you? No, because everybody knows that NaOH, KOH, RbOH, cesium OH, these are something that are very predominant in our laboratories, right? We have always seen it. Great. Okay. Now, beryllium hydroxide, okay? Beryllium hydroxide, BeOH2. It does not react with cold water. Okay, why? Small size. Yes. So let's write that down here, that Be, due to its small size, okay? Due to its small size, does not react with cold water or hot water. Due to its small size, does not react with cold water or hot water. Please do remember this, everybody. Beryllium hydroxide is not formed, okay? Beryllium hydroxide is not formed. Clear? All right. Moving on from here, then what do we have? Magnesium. Magnesium also does not react with, when magnesium is heated with, when magnesium is made to react with cold H2O, you will see that there is no reaction, okay? There will be no reaction. But magnesium does react with hot water. It does react with hot water, and what does it form? It forms MgOH2, okay? Plus obviously hydrogen gas. Plus obviously there is hydrogen gas that is formed. All right, everybody. Now, the rest of the elements that are there, they do react with cold water, okay? They do react with cold water as well as they do react with hot water. So what will happen here? Ca, calcium, strontium and barium. What do? They react with cold water or hot water. What do they give you? They will give you CaOH2 plus H2. You will get SrOH2 plus H2, and you will see that BaOH2 plus H2. Yes, this is an exception, okay? This is an exception, everybody. Okay, all right. Is this clear, bachos? Is this clear, everybody? Great. Now we come to after water, okay? After water, let's come to metal hydride, reaction with hydrogen gas. Now that we see that hydrogen gas is coming out, let us see how the hydrogen gas reacts with it, okay? So reaction with hydrogen. Reaction with hydrogen. Reaction with H2, okay? What do you think will form? What do you think it will form? Metal plus H2 will form what? Hydride, isn't it? So metal plus H2 will definitely give you a metal hydride, isn't it? It will give you a metal hydride. So very similarly, just like that, we will again make two groups, and here we will see that group 1 will form a hydride of MH nature, that is MH. M is the metal and H is for hydrogen. Here you will see that it will form MH2. Okay. So let's write it down. That means that Li, lithium, sodium, potassium, rubidium, cesium. Right? Yes, that's it. Yeah. All of them, when they react with hydrogen, what do we get? We get LiH, NaH, KH, RbH, and you will get CSH. Okay. And you will get CSH. Now, when we come to this side, we will see that we will have beryllium, magnesium, calcium, strontium, and barium. These, when they react with hydrogen, what will you get? You will get BeH2, right? You will get MgH2, you will get CaH2, you will get SrH2, and you will get BaH2. Am I clear? Is this clear, everybody? Yes, is this clear, guys? Cool. Now we come to reaction with halogen. What do we do? Reaction with halogen, because we have to see how are the halides that are formed. Okay, how do the halides they form? Okay, all right, everybody. Yes, this chapter is, oh, that's so sweet. Thank you so much, Hari. Thank you so much. Okay, chalo, let's get back to reaction with halogen. Reaction with halogen, everybody. What is reaction with halogen? Reaction with halogen is fluorine, chlorine, bromine, iodine, astatine. What do you have? Fluorine, chlorine, bromine, iodine, astatine. Yes, all right? Yeah. So, chalo. Let's learn about it. So, tell me, group 1. What will group 1 form? Everybody, I'm pretty sure that you know it, that group 1 will form monohalides, isn't it? They will form monohalides because obviously they are monovalent, isn't it? And these guys, they will form dihalides because they are divalent in nature, right? So what will we see? We will see that lithium, when lithium reacts with X2, X2 is basically, X can be a halogen. X can be fluorine, chlorine, bromine, iodine, astatine. All right. So Li plus X2 will give you LiX. Yes. Very similarly, you will have Na plus X2 will give you NaX. All right. Similarly, potassium plus X2 will form Kx. Right, everybody? Then you have Rb plus X2 forms RBX, and you have CS plus X2 which forms basically CSX. Am I clear, everybody? Is this clear, guys? Similarly, here also the only difference is that they will form what? They will form dihalides. So that means that if I have beryllium, beryllium plus X2 will give you BeX2. All right. Then you have Mg, then you have calcium, then you have strontium, and then you have barium. And all of that, if they react with X2, X2, X2 and X2, what will they form? They will form MgX2. Here it will form CaX2. Here it will form SrX2. And here it will form BaX2. Am I clear, everybody? Yes, am I clear, everyone? Great. All right. Acha, by the way, one thing that you also have to remember, okay, one thing that you also have to remember is that BeH2. See, I just spoke to you about BeH2, right? BeH2 and BeH2 is not formed just like this. BeH2 cannot be formed this way, okay? BeH2 cannot be formed this way. Do you know why? Because it's just difficult. Because it is just difficult. So let's write it down that for BeH2 to form, you have to take beryllium chloride. Okay, so you take BeCl2 and plus you mix LiAlH4. All right, and then from here you get BeH2 plus obviously what will you get? You will get LiCl plus you will get AlCl3, isn't it? Yes. So this is something that is important. Okay, this is something that is important and you probably have to remember it. Okay, this is something that is important, guys. Okay, all right. Please just make it, put it in a box. Put it in a box so that you remember it. Put it in a box so that you remember it. Okay. Acha. Now tell me something that if we have to talk about, are these hydrides, are these ionic or are these covalent? Are these hydrides ionic or are they covalent? How are we going to say? We know something called as Fayon's rule, right? And Fayon's rule has told us, Fayon's rule always tells us that what? SCLA. What is SCLA? SCLA means small cation, large anion. Small cation, large anion will form what? They will always form covalent compounds. But here, in case of these hydrides, in case of these group 2 hydrides, we will see, or the group 1 hydrides, we know that what are these? These are not small, right? They are in fact the largest in size. They are largest in size, isn't it? So what do we say? We say that all hydrides are ionic compounds. All hydrides are ionic compounds. All hydrides are ionic compounds. But lithium is obviously smallest, isn't it? But lithium is obviously smallest, isn't it? So all hydrides are ionic, but lithium sometimes forms covalent compound, okay? Lithium forms, Li forms covalent. Li forms covalent compounds as well, okay? Li forms covalent compound as well. Vedan, no. You can study S block, then you can study hydrogen, okay? Then you can study hydrogen. It's not very interlinked also. It's not very interlinked, okay? All right. Now, I was talking to you about dihalides, right? So dihalides, when we say, especially about beryllium, you will see that BeCl2 and BeF2 cannot be formed directly. What did I say? I said that BeCl2 and BeF2 cannot be formed directly. So the question is, then how can you form it? Right? You will need some special preparation method. What is the special preparation method? Very simple, very easy. Nothing much that you have to read about, okay? Just learn it like this. For BeF2, what we will take is, we will take ammonium berylate. What will we take? Formation of beryllium. Okay, formation of BeF2. What do we take? We take ammonium, NH4 berylate, ammonium berylate, NH4 BeF4 if you take. Then this will give you NH3 plus BeF2. This is how you form BeF2. What about BeCl2 then? What about BeCl2? How do you form BeCl2? For the formation of beryllium chloride, what you have to take is, you have to take beryllium oxide BeO plus add some carbon and add some chlorine to it. What will you get? You will get BeCl2 plus you will get carbon monoxide. Okay, plus you will get carbon monoxide. Got it? All right, everybody. This is clear, guys. This is clear. So reaction with water is done, reaction with hydrogen is done, reaction with halogen is done, reaction with air is done. What more? What more? Anything else is left? Is there anything else that is left? Reducing character. Yes. Let's learn about reducing character. Achha, here are certain things that you have to learn. That BCC crystal, alkali metals, the group 1 metals, they have BCC crystal structure. However, lithium forms HCP, that is hexagonal close packing. Okay, what does it form? It forms hexagonal close packing. Clear? All right. Yes, everybody. Now, moving on from here. They have loose packing, 68% packing efficiency. Why do they have loose packing? That's because they are bigger in size. More is the size of the atom. What will happen? They will also leave more void, right? They will also leave more void. The voids will also be bigger in nature, isn't it? Yes. Then what do we have? What else is there? Order of melting and boiling point. I have already told you. Order of melting and boiling point. I have already told you. What else is there? What else is there? Let's read about the reducing nature. Chalo. Let's read about reducing properties. Okay. Chintu, very good. इसको कहते हैं, there is a proverb in Hindi that says that 7 खंड रामायण के बाद सीता किसके पिताश्री है. इसका मतलब, this means Ramayana has 7 parts. Okay, Ramayana has 7 chapters. After all the completion of the 7th chapter, somebody will come and ask you, ma'am, was Sita Ram's father or what? This is the exhibition A of that. Yeah. I have come to the reducing nature of group 1 and group 2, and now you are coming and asking me, ma'am, what makes the difference between alkali metals and alkaline earth metals? Chintu, please watch the session from the very beginning so that you understand, yeah, and don't give me a heart attack suddenly like this. Chalo guys, what was I telling you? Let's talk about reducing property. Reducing property. What is the reducing property? Okay, what is the reducing property? So you have to know that you again have group 1 and you have group 2. Acha bachos, do you remember that when we were doing this redox reaction, yes, we were doing a chapter called as redox reaction. Then we did a chapter called as electrochemistry, and in those we have learned about something called as electrode potential. There was a chart of electrode potential. Do you remember? There was a chart of electrode potential, and there we saw that some elements they have negative value, some elements they have positive value, and we also saw that fluorine had the most amount of positive value, whereas the other elements they had negative value. So you have to know one thing, that is that more is the negative value more reducing nature. Okay, more negative value, more negative value, more reducing nature, more reducing nature. Crystal clear, everybody? Yes? No, not crystal clear. What do we say? Clinical clear. Is this all clinical clear? So you have to know that these group elements, they are strong reducing agent. Okay, both of these are actually strong reducing agent. They are strong reducing agent. Am I clear? All right. And lithium is the strongest reducing agent. Okay. Out of this also, lithium is the strongest. Okay. Lithium is the strongest. All right. Why? Because lithium also has very high hydration energy, right? Lithium also has very high hydration energy. Didn't I tell you that they're very small size? They're very small size. So what happens? High hydration energy. But okay, now you might be asking that, ma'am, what is the relation between reducing nature and hydration enthalpy? What is the the relation between reducing nature and hydration enthalpy? Do you remember when I was teaching you DNF block elements? Do you remember when I was teaching you DNF block elements and we were learning about something called as electrode potential and everything, and we also said that copper does not want to stay in its Cu2 plus state. Copper has a tendency to get back to its metallic form, solid form. Do you remember? Do you remember? And we also said that whenever there, okay, for example, for copper to get converted to Cu2 plus, yes, for copper to get converted to Cu2 plus, if you remember, my dear students, I have told you that first of all, what will you have to do? First of all, for copper to get into the Cu2 plus state, right? Cu2 plus, and also it is in liquid state, that means aqueous form. This is in aqueous form and this is in solid form. So from solid, what will I have to do? First of all, I will have to give it some sublimation energy, right? What do I have to give it? I will have to give it some sublimation energy so that I can take it to gaseous state, right? Once I take it to gaseous state, then I have to give here ionization energy 1 plus ionization energy 2, right? Do you remember that? Yes, do you remember that? Right? Then it will come to Cu2 plus. Once it comes to Cu2 plus, then hydration energy will be released. Hydration energy will be released. You give the atom ionization energy and sublimation energy, and then hydration energy is released. So that means, bachos, that means rubbing this was only for you to understand, okay? This was only for you to understand. So that means we can clearly understand that for any element to be to get into its reduced form, for any element or an atom to get into its reduced form, there are three energies that are required, isn't it? Yes, there are three energies that are required. What are the energies that are required? You require, first of all, you require sublimation energy. Yes, first of all, you require sublimation energy. Yes. Then what do you require? Then you require ionization energy. And finally, the third one is hydration energy, isn't it? The third one is hydration energy, and it always is seen that hydration energy is the deciding factor. Okay, hydration energy is the deciding factor. For what? This is what? On this the reducing power depends on. Reducing power depends on these factors. Okay, reducing power depends on these factors. All right, reducing power depends on these factors. So we know that whenever the hydration energy is more, it will also be a strong reducing agent, and that is why we see that lithium is the strongest. Why? Because high hydration energy. High hydration energy. Is this clear, everybody? Is this clear? Making sense or nonsense? All right, make sense or nonsense? And similarly, in case of group 2, we will see that beryllium will be a very strong reducing agent. Okay, beryllium will also be a very strong reducing agent. And why will beryllium be strong reducing agent? Once again, it will have high hydration energy. High hydration energy, or we can write small size, so high hydration energy. Right? Yes, this is also what? This is also small size, so high hydration energy. Small size, so high hydration energy. Am I right? Am I right, everybody? This is clear? This is clear? Everybody, is this clear? Is this clear? All right, all right, all right. Chalo. Now what do we need? Okay, just a minute. I need more extra pages. After reducing nature, now we have to read about Manjeet. What do you want me to repeat? What do you want me to repeat? Can you just go back and watch it? Can you just go back and what do you want me to repeat, Manjeet? You have to tell me what you want me to repeat. I'm already done more than 1 hour of the session, right? I've started this class around 4:40. More than 1 hour of the session is done. So what do you want me to repeat? You have to tell me. What do you want me to repeat? Anyway, guys, now let's learn about the reaction with liquid ammonia. Okay, this is very important. From here, you can definitely expect a question in your JEE mains. I'll tell you exactly from where as well. Okay, all right. Now, what are we going to learn? We are going to learn about reaction with liquid ammonia. Okay, reaction with liquid ammonia. This is very, very, very important, guys. Please, please, please focus up. All right. Please focus up, everybody. Please focus up. Okay. So what happens is both group 1 and group 2, they both dissolve in liquid ammonia. What happens is both of them, they dissolve in liquid ammonia. And once they dissolve, okay, once they dissolve in liquid ammonia, dissolve in liquid ammonia, and here also we can write that this also dissolves in liquid ammonia. Okay, this also dissolves in liquid ammonia. But here they show color. Okay, here they show color, and this is where the important part starts. Okay, what happens is the group 1 elements, they show a deep blue color. What do they show? They show a deep blue color, and here you will see a deep blue black color. What do you see? You see a deep blue black color. All right, this is what you will see. And you will also see that both of them are conducting in nature. What will you see? You will see that both of them are conducting in nature. Why? I will tell you. This is conducting in nature, and so is this. This is also conducting in nature. You know why? Because the metal, okay, the metal, what it does is, the metal reacts with some amount of NH3. Let's just write it as X plus Y NH3. You will see that the reaction is somewhat, the reaction that is formed here is somewhat, everybody please have a look, focus up. You will see that it forms MnH3X. It forms a coordinate complex here. All right, this is the positive part. And you will see that there is an ammoniated electron. What happens? You will see an ammoniated electron, everybody. Okay, what is this ammoniated electron? See, it will form NH3. Here will be the Y, and this will be the minus part. So what do you call it? You call this to be as ammoniated electron. This is called as ammoniated electron. Because of this ammoniated electron, you get to see the deep blue color, you get to see the conducting nature, and you get to see that it is dissolving in liquid ammonia, all because of this ammoniated electron, everybody. Now, if I'm calling this as ammoniated electron, what can I say this? What can I call this? I can call this as ammoniated metal. I can call this as ammoniated metal, isn't it? I can call this as ammoniated metal, everybody. This is very, very, very important. Okay, what type color it would be? Deep blue color. Deep blue color. Okay. Now, because of this ammoniated electron, you will see that this is also paramagnetic. This is also paramagnetic in nature. Okay. This is also paramagnetic in nature. Apart from that, one more important thing is, now if you keep the solution, okay, if you keep the solution for longer hours, undisturbed, Undisturbed, keep the solution for longer hours. Undisturbed, keep the solution for longer hours. Okay, for longer hours. Do you know what you will see? Do you know what you will see? You will see that there is amide formation. Yes, now I just told you, right? It forms ammoniated metal. This ammoniated metal, this will lose NH3. From NH3, it will lose another hydrogen and it will form MnH2, which is nothing but, what is this? This is amide formation. Okay, what happens here? Amide formation happens. Is this clear? Is this clear? Now, by chance, let's say that if I take concentrated solution, if I take a concentrated solution, then what will I see? If I take a concentrated solution, then what I see is, do you remember this ammoniated electron? Now, this ammoniated electron formation happened. This ammoniated electron formation happened when I took dilute solution. If I take concentrated solution, now what happens is the clumping of the electrons happen. The clumping of the electrons happen, and because the clumping of the electron happens, what happens is this becomes diamagnetic. Okay, this becomes diamagnetic. All right, and this diamagnetic solution, it also becomes bronze color. It also becomes bronze color. It no longer shows the deep blue color, but it forms bronze color. All right, yes, everybody. All right, great. Now moving on here to the group 2. Okay, in group 2, what is the kind of reaction that you will see? You will see that M plus X plus Y NH3, it will give you, once again, you will see ammoniated metal. There will be ammoniated metal, which is the positive part, and you will also see the ammoniated electron. However, just to balance it, this time you will see 2. Okay, this time you will see 2 of this. Okay, all right, everybody, is this clear, guys? Is this clear? So reaction with liquid ammonia is also done. Okay, now what do we do? Now what do we do? Now let's learn about reaction with acid. Yes, reaction with acid. Why? We just saw, no, these were forming what? Basic oxides they were forming. So obviously they will react with acid, and what will they form? They will react with acid, and you know what will they form, right? You know what will they form, isn't it? Yes. So any metal you take, okay, let's write it down here. Reaction with acid. Reaction with acid. Here, guys. Let's take it, okay? Let's take it. Let's say that we take the metal M plus HCl. What will you see? It will form MCl plus obviously hydrogen gas. All right. And here, this side, you will see that M plus 2HCl will give you MCl2 plus obviously hydrogen gas will be evolved. Okay. Both the side, you will see that hydrogen gas will be evolving. Here you will see that it will form LiCl. There will be LiCl, then NaCl, yes, lithium, then NaCl, then there will be KCl, then there will be RbCl, and then there will be CsCl. All right. And this side, what will you see? This side, you will see that there will be formation of BeCl2, there will be formation of MgCl2, there will be formation of CaCl2, there will be formation of SrCl2, and there will be formation of BaCl2. Am I clear, guys? Am I clear? All right, everybody. Yes. Acha. Now, one more thing that we have to study is, we were done with this oxide, peroxide and superoxide. I have taught you, right? Oxide, peroxide and superoxide I have told you. So let's do hydrolysis of oxide, peroxide and superoxide. Okay. Let's do hydrolysis of oxide, peroxide and superoxide. All right, let's have a look at that. Let's have a look at that. Okay. All right, let's have a look at that. So what will it be? What will it be? Acha, chalo. If I take oxide, that means let's say that we take M2O. M2O is the oxide. So M2O plus hydrogen plus water will give you, you know what? It will give you M plus OH minus, right? Now, if I take peroxide, which is basically M2O2, right? Now, M2O2 plus water, when I take, do you know what it will form? It will form M plus OH minus, obviously, plus it will form hydrogen peroxide. All right. Now, finally, if I take superoxide, that is MO2 plus water, if I do, then it will form M plus OH minus, yes, plus it will form, obviously, superoxide, hydrogen peroxide. Sorry, what did I say? Just a second, guys. OH minus plus it will form hydrogen peroxide plus oxygen gas. Okay? Plus oxygen gas. Am I clear, everybody? Am I clear? All right, everyone? Yes. Now, we all know that when the alkali metal oxides, when they react with water, they will form basic hydroxide, and the alkaline earth metal, apart from beryllium, they will form basic hydroxide. Beryllium will form amphoteric hydroxide. Okay. Beryllium will form amphoteric hydroxide. Yes, everybody. This is clear, guys. This is clear. Yes. Now, moving on. What else do we have to study? Ionization potential I've taught you. Oh, yeah, okay, let's do this. The first ionization potential is actually very less. Please have a look, everybody. The first ionization potential, I was talking to you about ionization energy, isn't it? The first ionization energy is obviously very less because they want to give away one electron and they want to get into their noble gas configuration. However, the second ionization energy is really high, okay? The second ionization energy is really high, all right? Yes. And here in the group 2 elements, you see that the second ionization energy is lesser than the group 1 second ionization energy. Now, shall we do a question here, guys? Let's do a question here, okay? Let us take a look at the question. What is the question? Where is the question, guys? Liquid ammonia is done. Solubility in liquid ammonia is done. Photoelectric effect. Okay. Photoelectric effect we will do. But before that, let's do a question here. Where is the question? The sequence of ionic mobility in aqueous solution is. Can somebody tell me what is the sequence of ionic mobility? Let me tell you that ionic mobility as you go down the group will increase. Why? Because lesser the hydration enthalpy, right? Lesser is the hydration enthalpy. That means the water molecules are not holding on to the atom. So the mobility will increase. Now tell me what is the answer. Now tell me what is the answer, everybody. Is it option A, potassium, then sodium, then rubidium, and then cesium? Or is it cesium, rubidium, potassium, and sodium? Or is it rubidium, then potassium, then cesium, and then sodium? Come on, guys, tell me. What do you think is the answer? What do you think is the answer, everybody? Come on. Quickly tell me. Quickly. Tell me, guys. What is the answer? The answer, obviously, I just told you, as you go down the group, the ionic mobility increases, and we know that it is lithium, then it is sodium, then it is potassium, then it is rubidium, and then it is cesium. So cesium will have the highest, then it will be rubidium, then it will be potassium, then it will be sodium, and then it will be lithium. Lithium will have the least ionic mobility. This is clear, guys? Yes. Chalo. Okay. Now let's come to hydration energy. We have studied already. Standard oxidation potential also we have studied pretty much, right? Photoelectric effect. Let's do photoelectric effect, everybody. Now, atomic size of potassium, rubidium, and cesium is very large, right? So what happens is that their ionic potential or ionization energy is very low. And because they have such low ionization energy in their valence shell, you have to understand that the threshold, that means that with a very low energy of light also they can give away their electrons. Yes, they can release the electrons. So that is why we see that cesium is used in the photocells. Cesium is used in the photocells, and then we see that the group 2 elements, that is alkaline earth metals, they do not show this property as the ionization potential is higher than the group 1 elements. Am I clear, everybody? This is done, this is done, this is done. Complex formation tendency, we have already learnt about this. We all know that magnesium is present in chlorophyll, right? And chlorophyll is a coordination complex, which we have studied long back, right? Yes, high charge density, all of this is done, all of this is done. Then we do reactivity is also done. They are very reactive. They are not found in free state. Okay. Reaction with air is done. Reaction with oxygen is done. Reaction with hydrogen. Reaction with water. Halides is done. Carbonates. Okay, carbonates. Yes. So what happens is the alkali metals, right? The alkali metals, they form carbonates of the type M2CO3. What type of carbonates do they form? They form M2CO3 type of carbonates. All right. Whereas the alkaline earth metals, that is the group 2 elements, they form MCO3. Now, in the group 2 elements, the most famous carbonate is obviously CaCO2, that is calcium carbonate. Calcium carbonate, if you heat it, it breaks down, it decomposes to carbon monoxide and carbon dioxide. All right. Actually not, it forms CaO, calcium oxide plus CO2. Oxide plus CO2, CaCO3, yes. This is the one, calcium oxide plus CO2, okay. This is what it breaks down into. Now, if you take Li2CO3, except Li2CO3, all the carbonates are stable towards the heat, okay. All the carbonates, they are stable. However, lithium carbonate, if you just give it some amount of heat, what happens is it breaks down to lithium oxide and carbon dioxide, okay. Thermal stability of carbonates, how is it dependent on? The thermal stability of carbonates is dependent on, inversely dependent on ionization energy. So if the ionization energy increases, then what will happen? Thermal stability will be less. That is why ionization energy of lithium is very much high, isn't it? Ionization energy of lithium is very much high, which is why thermal stability is not so much. Clear hai? Then there is nitrates. Nitrates also we have spoken that only lithium stability increases from LiNO3 to CsNO3. Nitrates, they form MNO3 and here they form MNO3 type. Yes, BeNO3. Okay. Beryllium. See, beryllium has, we will also read about diagonal relationship. In some time, we will also read about diagonal relationship and we will see that beryllium shares similarities with aluminium. So, you know how aluminium does not react with nitrogen and oxide very well because there is a oxide layer forms which makes aluminium passive. Similar case happens with beryllium as well. BeNO3 forms the layer of beryllium oxide on its surface and then it becomes passive. It does not react anymore. Clear? Then there is nitrides and sulfates. All of these you can just read it once. Basically, this thing is pretty much same. Okay, the properties are very similar, but here is one thing that you have to remember, that lithium sulfate is the least soluble in water. Okay, lithium sulfate is least soluble in water. All the alkali metal sulfates, they are ionic in nature. Yes, they are all ionic in nature. All right, and here what happens is the solubility of beryllium sulfate to barium sulfate. Okay, solubility of beryllium sulfate to barium sulfate, what happens is it decreases. Why does it decrease? Why does it decrease? Because Be2 plus and Mg2 plus are of small size and that is why their hydration enthalpy is more. If the hydration enthalpy is more, then what will happen? If the hydration enthalpy is more, then the solubility is also more. Okay. If the hydration enthalpy is more, the solubility is also more. Am I clear, everybody? Is this clear? Okay, now tell me. On heating, which of the following releases CO2 most easily? On heating, which of the following releases CO2 most easily? We have just learnt about it, isn't it? Carbonates. What happened to the carbonates? See, order of decreasing stability. We know that MgCO3 has a very less stability, isn't it? MgCO3 has less stability. So now you tell me what is the correct answer. Obviously, the correct answer is MgCO3. MgCO3 has least stability. So the moment you start heating it, what will happen is it will easily give out carbon dioxide. Okay, it will easily give out carbon dioxide. All right, everybody. Now what do we have to talk about? Anomalous behavior. Chalo, let's talk about anomalous behavior. Okay. Anomalous behavior, I think I've told you already. But before that, I also want to teach you BeCl2. Let's teach you BeCl2. How BeCl2 and aluminium, diagonal relationship we will talk about now. We will talk about diagonal relationship as well. So let's learn about BeCl2, okay? Now in group 2, this is important, okay? In group 2, what happens is, group 2, you get to see that BeCl2 formation, right? And BeCl2, just like how AlCl3 exists, you will see that in solid state, okay? In solid state, it shows a polymeric form, alright? It shows a polymeric form. Cool, everybody? Yes. Now, in vapor state, what happens? In vapor state, you will see that it forms a dimer, alright? Yes. And it also does exist as a monomer, by the way. Yes, it does exist as a monomer, but at what time? When does it exist as a monomer? You will see that at temperature greater than or equal to 1200 Kelvin, you will see that it exists as a monomer. So what is it? When does it form monomer? When you heat it at 1200 Kelvin, when you heat it at 1200 Kelvin or more than 1200 Kelvin, it becomes an electron deficient, okay? It becomes electron deficient, and this is how the structure remains, okay? This is a linear structure that it forms only at this temperature, only at this temperature. Now, what is the polymeric form? The polymeric form, you will see that it exists like this: BeCl, Cl here, then you will see Be here, then you will see Be here, Cl, Cl, Be, Be, and once again you will see that this side is Cl, this side is Cl, this side is Cl, this side is Cl. Okay, so this is the polymeric form. What is the dimeric form? The dimeric form, you will see once again that Be here, Cl here, Be here, Cl here, Cl here, Cl here, and Cl here. This is your dimeric form. Okay, this is your dimeric form. All right, everybody, is this clear, guys? Is this clear? Chalo. All right. That diagonal relationship, we will do it in some time. But now let's go and understand oxo acids. Okay. Should we do oxo acids first, or let's do anomalous property? Chalo. Let's do anomalous property because that's easier. Acha. So initially, first of all, let's understand that why do you get to see the anomalous properties of lithium? If you remember that in P block, I kept telling you about it again and again, again and again, again and again. Don't you remember? That in P block, we saw that anomalous properties are showed by the first elements in a group. Why? Small size. Why? Absence of d orbital. Why? High ionization enthalpy. Why? High electronegativity as well. All right. Yes. And that is why you get to see the anomalous behavior of lithium. And very similarly, just read it, everybody, what is written. Due to its small size, it exerts the greatest polarizing effect out of all the alkali metals and ions. Consequently, covalent character is developed. Fayance rule. This is basically nothing but your Fayance rule, isn't it? This is your Fayance rule. Polarizing character increases. So that is it. It has high ionization energy and high electronegativity. We have already spoken about it. It is not affected by air easily. We have also spoken about it, right? And it reacts slowly with water to liberate hydrogen gas, right? Then when we come to beryllium, anomalous behavior of beryllium, we see that it is hardest of all the alkaline earth metals, right? Because of why? Maximum metallic bonding, also small size. Because of its small size, the overlapping will also be very easy, right? And because it is closer to the nucleus, so what will happen? The bonding will also be stronger, which is why you get to see an anomalous property of beryllium. The melting point and the boiling point of beryllium are the highest, and we see that it is also least reactive due to high ionization energy. Right? Then we see that lithium oxide is much less basic oxide than the other alkali metal. It is the only alkali metal which directly reacts with nitrogen to give you Li3, and I remember I told you that. Remember I told you that it behaves differently. It behaves differently. Haven't I told you that? Yes. Then what happens is lithium hydroxide decomposed by red heat. When you heat it at very high temperature, lithium hydroxide, it decomposes and it gives you lithium oxide. Yes, it gives you lithium oxide, which the other alkali metals, they do not decompose, because we just some time back only we spoke na, that thermal stability increases as you go down the group. Thermal stability, what happens? Thermal stability increases as you go down the group. We will also see that LiHCO3, that means that lithium hydrogen carbonate is known in solution but not in, okay, this is somewhere, this is where you have this thing, the slides are hiding, but not to worry, I will tell you what is written here, okay. I will tell you what is written. It says that lithium hydrogen carbonate is known in solution but not in solid, okay, but not in solid state, while the carbonates of other alkali metals are known in solid state. That means lithium hydrogen carbonate is known in solution but not in solid. That means in solid form you will not find it. LiHCO3 does not exist as solid, does not exist as solid. Clear hai? All right, everybody. Yes. Then we said that. Then we talk about the group 2, that is beryllium. Beryllium also has high charge density, and that is why the polarizing effect is highest, and it does form covalent bond. Once again, Fayon's rule. It dissolved in alkalis with evolution of H2. Do you remember? Yes, we have spoken about it. Yes, we have spoken about it. Beryllium will react with sodium hydroxide and it will produce hydrogen gas. Okay, it will produce hydrogen gas. Here, what is forming? This right here is your sodium berylate. It forms sodium berylate. Okay, sodium berylate. Whereas other alkali metals, other alkaline earth metals, they do not react with alkali. It's only shown by beryllium. This behavior is only shown by beryllium. Other alkaline earth metals, they do not show this. Okay. All right, everybody. Then we also know that oxides and hydroxide of beryllium are amphoteric in nature, which is once again not seen anywhere else. All the other alkaline earth metals, they form basic oxides, isn't it? Also, this hydroxide is unstable in water and it is covalent in nature. And just like aluminium, beryllium also forms its carbide on hydrolysis will give you methane. Aluminium carbide also gives you methane and beryllium carbide will also give you methane. Alright everybody, is this clear guys? Is this clear everybody? Yes, very nice. Then because of its small size, it also has a tendency to form complexes. So it will form complexes and it shows diagonal relationship with aluminum, which we will study now. Okay? Then here we see that lithium carbonate is less stable as it decomposes on heating, which we told you that thermal decomposition, thermal stability increases as you go down the group, right? But lithium being on the top has very low thermal stability. Okay. Lithium sulfate is the only alkali metal sulfate which does not form double salt. Okay. Which does not form double salt. Lithium, when you heat it in NH3, it forms imide. What is imide? Imide is Li2NH. Imide is Li2NH. And what is amide? Amide is LiNH2. Okay. LiNH2 is amide. What is imide? Li2NH. That is your imide. Okay. While all the other alkali metals, they form amide, but only lithium forms imide. Got it, guys? Then we have the diagonal relationship, the similarities of lithium and magnesium, and we all know that both lithium and magnesium, they're harder and lighter than the other elements, right, in their respective group. Both of them, they react with only cold water. We have spoken about this, yes. And their oxides and hydroxide are much less soluble in water. Why? We also know about it, right? We also know about it, right? And then we also know that they decompose on heating. The hydroxides that decompose on heating, both form a nitride by direct combination with nitrogen, right? Whereas in the group 1 elements, you saw that apart from lithium, nobody else was forming a nitride, isn't it? The oxides, Li2O and MgO, they do not combine with excess oxygen to give you a peroxide and a superoxide. However, a little amount does. A little amount does, right? The carbonate of lithium and magnesium, they decompose easily on heating to form the oxide and carbon dioxide. Thermal stability is less. Solid bicarbonates are not formed by lithium and magnesium. We have just spoken about it, right? Both LiCl and MgCl2 are soluble in ethanol. Of course, both LiCl and MgCl2 are deliquescent. That means that they have the capacity to hold on to the water. They have the capacity to hold on to water molecules, and which is why even our normal salt, sodium chloride, right? Sodium chloride, if you keep it in open, haven't you seen that it is hygroscopic in nature? And do you know why it is hygroscopic in nature? Because there are impurities like MgCl2 and calcium chloride. Both MgCl2 and calcium chloride are deliquescent in nature, which is why even our normal, the common salt becomes hygroscopic. It has the tendency to attract water, right? Now, coming to beryllium and aluminium, I have already told you that both have the same electronegativity and they have the same charge radius ratios. Both metals are fairly resistant to the action of acids because of a protective layer that is formed, right? Then we also know about both metals are acted upon by strong alkalis to form soluble complexes like berylates and aluminates. The chlorides of both the metals, they are bridged like this. Yes, I have just spoken to you. Salts of these metals, they are form hydrated ions, for example, BeOH242 minus and AlOH263 plus in aqueous solution. Okay, they stay in aqueous solution. Once again, because of the similar charge, this thing ratio. Okay. All right. Is this clear, everybody? Is this clear? Then comes the oxide, superoxides, oxide, peroxide, and superoxide. That also I have explained to you. Hydrolysis is done. Hydrolysis of oxides is done. Right, everybody. This is all done, guys. This is all done. This is also done. So, oxo acids, yes. Now let's learn about oxo acids, yes. Let's do oxo acids. Chalo. Where is the khali slide, guys? Where is the khali slide? Here. Let's take a look at oxo acids, everybody. Okay. Oxo acids of, then we will have H2SO4 and then we will have HNO3. Okay, HNO3. So here, what will you see? What is the structure like? The structure will be COH here. Then here also you will have an OH because 2H, and then this will be double bond O. Then here you will have S, double bond O, one OH here and one OH here, right? H2SO4, great. Then you will have nitric acid. So this will become OH here, double bond O, and here you will get a coordinate bond, that is O. All right. Now, what are the characteristic of this oxo acid? The characteristic of the oxo acid, everybody, is, okay, the characteristic of the oxo acid, you will see, everybody, do you see that there are hydroxyl group, that is OH, OH. And to the same element, to the same atom, you also have an oxo group. Do you see you also have an oxo group? Yeah. So this is the characteristic. The characteristic, if you have to write down that there has to be a hydroxyl group. There has to be a hydroxyl group. Okay. All right. There has to be a hydroxyl group. All right. Then what do you have? Then you also have an oxo group. All right. Then you also have an oxo group. Am I clear? And finally, what do you have? You also have the oxo and the hydroxyl group. Okay. Hydroxyl group and the oxo group connected to the same atom. Okay. Connected to the same atom. Okay. Connected to the same atom. This is the clear case. Alright guys, this is the clear case. Now everything else is done. Sulfates are done. Anomalous behavior is done. Everything is done. Acha, now we have to go to some important compounds. Okay, let's learn about some important compounds of. Alright guys, we have to learn about some important compounds of group 1 and group 2. Shall we? Everybody, are you all with me? Some important compounds of group 1 and group 2. Okay, some important compounds. Chalo. Now, what are the important compounds of the group 1 elements? Let's learn about sodium carbonate, sodium chloride, and we have to learn about caustic soda. And we have to learn about caustic soda. Bole to what? Bole to NaOH, yeah. NaOH we have to learn about, right? So first of all, let's learn about preparation of NaCl. What do you all say? Let's learn about preparation of NaCl. Preparation of NaCl, bachus. What is the preparation of NaCl, everybody? How do you prepare? You will all be like, ma'am, why are you teaching this, ma'am? This is so simple. This is so easy. How do you prepare NaCl? Evaporation of seawater will give you sodium chloride, isn't it? Evaporation of seawater will give you sodium chloride. But is that why we are studying? No, bachus. In laboratory, you can also prepare sodium chloride by crystallization of brine solution. How do you prepare it? Crystallization of brine solution. Crystallization of brine solution will definitely give you sodium chloride. Now you're going to ask me, ma'am, what is this brine solution, ma'am? Brine solution is basically concentrated NaCl solution. What is it? Concentrated NaCl solution. All right. Yes. So you crystallize it. You crystallize it. Now after crystallization of brine solution, now what you do is you filter and remove the insoluble impurities. Okay, what do? You filter it out and you remove the insoluble impurities. Okay, remove the insoluble impurities, bachus. Okay, remove the insoluble impurities. Okay, then what do? The solution is saturated. The solution is saturated with. The solution is saturated with HCl gas. All right. The solution is saturated with HCl gas. All right. And then do you know what you see? What you see is here, I just told you about impurities, isn't it? What are the impurities that are present here? The impurities that are present here are, everybody, please note it down. The impurities that are present here are CaCl2, you have MgCl2, and these two are deliquescent in nature. Remember, I just told you that this is exactly why our normal common salt is hygroscopic in nature. Why? Because CaCl2 and MgCl2, they are more soluble, okay? They are more soluble than sodium chloride, and they do remain in the water only, okay? And they remain in water. So let's write down this as well. Calcium and magnesium chloride more soluble in water, okay? More soluble in water, and remain in the solution, all right? But apart from this two, apart from calcium chloride and magnesium chloride, you have two more impurities, and those are Na2SO4, that is sodium sulfate, and CaSO4. What are these? These are all impurities, okay? These impurities only you just removed. Cool hai bachos? Yes. Is sodium chloride done? Sodium chloride is done, okay? Now what do? Now we come to washing powder Nirma, detergent powder Nirma, दूध सी सफेदी निरमा से आए, रंगीन कपड़े भी खिल खिल जाए. That is why you call me Nirma ma'am, isn't it? So yes, let's do our Nirma. Let's do Nirma, everybody. Chalo. So what are we doing? Now we are going to do washing soda, washing powder Nirma. So we have washing soda. Yes, what is washing soda's formula? Washing soda's formula is Na2CO3 dot 10H2O. There it is a decahydrate. What do you have? It is a decahydrate. Why? Because there are 10 water of crystallization. Okay. So this is also with love called as sodium carbonate. What is it called as? It is called as sodium carbonate. Now the preparation of sodium carbonate, okay, the preparation of sodium carbonate is done by Solvay process. What do? You do Solvay process, and this Solvay process is also called as ammonium soda process. What is it called as? It is also called as ammonia soda process. Ammonia soda process. This process has actually 4 steps and it is very easy. You will learn it right away. Okay. You will learn it right away. There are 4 steps, everybody. The first step is, what do? You take ammonia. See, I just told you, na, ammonia soda. So you take ammonia plus, what do? Plus water and plus carbon dioxide. What will you get? You will be getting NH4 2CO3. Alright, you will be getting NH4 2CO3. Now, step number 2, everybody. Take this NH4 2CO3, add again some water and carbon dioxide. Add some water, add some carbon dioxide. What will you get this time? This time you will be getting NH4 HCO3, that is ammonia hydrogen carbonate. All right. Now what do you do is, now do you want ammonia? No, you want sodium carbonate, right? You want sodium carbonate. So step 3, everybody. Step 3, you take this NH4 HCO3 plus add NaCl. What do? Plus add sodium chloride, but in excess amount. You will add excess amount of sodium chloride, and when you do that, what will you get? This time you will get NaHCO3. This is insoluble. This is insoluble, and plus you will get NH4Cl. Okay, plus you will get NH4Cl. All right, this is insoluble and it comes out as a precipitate. It comes out as a precipitate. Once you are done with this, now you have step 4, bachus. Step 4, what do? You take this NaHCO3, and we have been learning about this. All you have to do is just heat it up. Once you heat it up, what will you get? You will get Na2CO3 plus you will get H2O and plus you will get carbon dioxide. This is how you get it. Now, something that is very, very important is, everybody, this NH4Cl, this NH4Cl, from here you can recover the ammonia and you can continue this process. You can continue this process. You can continue this process. What do? You can recover ammonia, okay? Recover ammonia, recover NH3 from NH4Cl. How? What will you do? You will add CaCOH, right? You will add CaOH. No, calcium hydroxide you will add. You will add calcium hydroxide. When you add calcium hydroxide, you know what you get? You get NH3. Okay, you get NH3 plus CaCl2 plus H2O. See, your ammonia is recovered, and this ammonia will once again be able to run the reaction. So this is how you prepare washing powder Nirma. Okay, this is how you prepare washing powder Nirma. Cool, everybody. Now, do you know that just like how we have created sodium hydrogen carbonate or sodium carbonate, you cannot prepare potassium carbonate. Okay. Potassium carbonate cannot be prepared with Solvay process. K2CO3 cannot be prepared by Solvay process. Cannot be prepared by Solvay process. Do you know why? Why cannot it be prepared by Solvay process? That's because KHCO3, in between you will get NaH, just like how you got NaHCO3. Just like that, in between you will also get an intermediate product KHCO3, right? Yes, you will also get KHCO3, which is KHCO3 is soluble in water, which is why you will not be able to do this with Solvay process. Am I clear? Yes, everybody. Now, what are the properties here? What are the properties of sodium carbonate, everybody? What are the properties of washing powder Nirma? The properties of washing powder Nirma is, first of all, this is washing soda. First of all, this is washing soda. Yes. Then, of course, because it is washing soda, it is soluble in water. Make sense or nonsense, everybody? This is soluble in water. Make sense, everybody? Now that it is soluble in water, that means that you also know that it is, what is the color of the washing powder that you use? What is the color of Nirma or Tide? Tide, what happens? क्यों चौंक गए? Tide जैसी सफेदी कहीं नहीं. Why do I know this detergent powder advertisement by heart? I have no idea. But it just stays rent free in my head. What to do? So anyway, these are white crystalline powder, isn't it? These are white crystalline powder, correct? These are white crystalline powder, everybody. And now that they are white crystalline in powder, I also told you that they are decahydrate because there are 10 water of crystallization. This is decahydrate, everybody. Clear hai, bachos? Clear hai? Acha, 7 p.m. I have another class, no? 7 p.m. I have another class. You know what? Let's push that to 7:30 or something. One second, guys. All right, everybody. Yes. Hi, Nishant. Hello, bacha. Welcome to the session. Okay. So this is done, everybody. Yeah, this is done. Now, what if we heat this Na2CO3? See, this is very simple, right? This is very simple, everybody. What if we heat this Na2CO3.10H2O? What will happen if we heat this? If we heat this at about 373 Kelvin, do you know what will happen? One of the water of crystallization, sorry, 9 water of crystallization will run away. 9 water of crystallization will run away and only 1 water of crystallization will remain. So from decahydrate, do you know what it will form? From decahydrate, it will become monohydrate. Yes. Decahydrate से monohydrate. What is it forming? From decahydrate, it forms monohydrate. Clear? Okay. Now, if I heat this above 373 Kelvin, okay? Let's take this monohydrate, that is Na2CO3 dot monohydrate. If I heat this above 373 Kelvin, okay? Above 373 Kelvin, then what will I get? I will get soda ash. What will I get? I will get soda ash. Na2CO3, soda ash, okay? What will I get? Soda ash. Soda ash, okay? Soda ash is a white fluffy powder, everybody. What is soda ash? It is a white fluffy powder. Alright guys, is this done? Clear hai bachos? Cool. Now, let's talk about baking soda. Now that we are done with washing powder, Nirma, let's also do baking powder. I don't know, whatever is the song. No baking powder song, I know. Sorry. Chalo, let's do baking powder. NaHCO3, that is baking soda. Acha, bachos, if you see clearly, baking soda, we had baking soda here, isn't it? We had baking soda. See, this soluble, this insoluble and PPT. Insoluble and it comes out as precipitate. So even in solvay process, you are getting some amount of baking soda, that is sodium hydrogen carbonate. But apart from that, you can also make it with Na2CO3. Plus, if you add water, plus if you add carbon dioxide, these two in excess form will also fetch you sodium hydrogen carbonate. Am I clear? Now, this sodium hydrogen carbonate, I'm pretty sure that you all know. Don't we use baking soda whenever we are bitten by a wasp or an ant or something? So that means that this is mild antiseptic in nature. This is mild antiseptic in nature. That's it. Easy peasy biryani tasty, everybody. Isn't this easy peasy biryani tasty? Great. Then finally we come to sodium hydroxide. What is sodium hydroxide? Sodium hydroxide, my dear students, are your caustic soda. Yes. Oops. What time did we start, guys? 4:40, isn't it? So from 4:40 to, not 4:40, I think we started it around 4:35, 4:30. So 4:30, 5:30, 6:30 over. It is already 6:51. It is about to be 7:30. In 3 hours, S block is over, guys. S block is over. So here we have NaOH, sodium hydroxide. Yes, 1 second, everybody. 1 second. First, let me get some more empty pages. I need more empty pages. That's it, done. Chalo. What are we doing? Now we are doing sodium hydroxide, है ना? Let's do sodium hydroxide. Okay, this is important. Sodium hydroxide बोले तो caustic soda is prepared with the help of a process that you already know, that is electrolysis. Okay, how do you prepare it? Yes, how do you prepare it? The process is electrolysis, but this electrolysis is done in, it is done in a cell. You remember electrolysis is done with the help of electricity, isn't it? With the help of electricity, you disintegrate something, you break something down. So here also you will be doing electrolysis, but in a very specific particular cell. Where will you do? Is done in, okay, this is something that you have to remember. You will have to do it in Kastner-Kellner cell. Where will you do? Kastner-Kellner cell. Okay, this is where you do the electrolysis, and you know what you will get, and you know what will you get, because this is this Kastner-Kellner cell. This Kastner-Kellner cell will have a cathode and it will have an anode, right everybody? If it is a cell always has electrodes, isn't it? A cell always has two electrodes, so you will have a cathode, you will have cathode. This is important. It has come as a match the following question. Okay, it has come in JEE mains as a match the following question, not even kidding. So cathode will have mercury, cathode will have mercury. In the cathode, you will be getting sodium as an amalgam. Why will you get it as an amalgam? Because the sodium reacts with mercury, and anything when it reacts with mercury, we say that it is an amalgam. Okay, this amalgamation of sodium and mercury, when you hydrolyze it, okay, on hydrolysis, it will give you sodium hydroxide, right? And in the anode, what will you get? What will you get in the anode, which is basically of a carbon rod? The anode is a carbon rod, and this anode, in the anode, you will be getting chlorine gas, bachos. Okay, in the anode, you will be getting chlorine gas. Okay, am I clear? So this brings you to the end of important compounds of sodium. Now we will go to some important compounds of calcium. Okay, some important compounds of calcium. Some important compounds of calcium. Yes, is this done, everybody? Let's just check out our NCERT book once. I'm guessing that everything is done, but I still want to check it out, because everything that is there in your NCERT, that too in the old NCERT, is something that we will be doing. Can you explain, Jen? Aruna, I have started organic chemistry from yesterday. Tomorrow again there will be a continuation of general organic chemistry. Don't worry, we will be doing organic chemistry. Yeah. Where is this block? Just a second, guys. Let's just check it out. Where is this block? S block is not there only. Yeah? Solid state P block, chemical kinetics. Acha, S block is in class 11th, right? This is class 12 book that I have. Chalo, no worries. I'm thinking that I have already explained everything that you need to know. But anyway, no worries. Yeah. Can you all please check it out? Is it worth learning this chapter? Yes. You will get questions from this chapter in JEE. So why not? You must. Okay. Chalo, guys. Moving on. Now, let's learn about calcium oxide first. Okay, all right. This calcium oxide, what do you call calcium oxide? Calcium oxide with love is called as quicklime. What is it called as? Quicklime. This quicklime is prepared commercially at around 1070 Kelvin to about 1270 Kelvin in a rotatory kiln. Okay, what is it called? Rotatory kiln. K-I-L-N. I don't know how to pronounce it. Kin, I guess. Rotatory kin. Rotatory kin. K-I-L-N. Kin. Okay, it is called as rotatory kin. All right, everybody. Yes, so what do you do? First of all, obviously, you will be taking calcium carbonate, that is limestone. Okay, you will take limestone. Then what you will do is you will heat it. Once you heat it, you will get CaO plus carbon dioxide. All right, plus carbon dioxide. That is what you will get. All right. Now, if you take this calcium oxide on hydrolysis, then on adding water, it will give you calcium hydroxide CaOH2 plus H2O is something that you will get. All right. And then what will happen is this CaO plus adding CO2, it will also give you calcium carbonate. So basically, this reaction is, reversible. You do this reaction, then you take the calcium oxide, and again you can get the calcium carbonate. Okay, and again you can get the calcium carbonate. Okay. All right, everybody. Now we understand that how do we get slaked lime? CaO was quick lime. How about CaOH2? That is slaked lime. How do we get slaked lime, bachas? How do we get slaked lime, everybody? You just have to add water to quick lime. That's what we saw, na? See, just add water to quick lime and you will get slaked lime. So what do? You take CaO, you take quick lime, then add water. What will you get? You will get slaked lime. That's it. This is the preparation. Okay. This is the preparation, everybody. And then you have those very basic reactions which you have learned in your younger classes, that lime water, when you mix carbon dioxide, it will turn milky. And then when you add excess amount of carbon dioxide, then the milkiness disappear, isn't it? We have read about all of these things, right? Now, one more thing that you have to know about is, if I take this, okay, if I take this calcium hydroxide, okay, slaked lime, and if I add chlorine to it, you know what I get? I will get calcium hypochlorite. What will I get? I will get calcium hypochlorite, and I will get calcium chloride, and this is basically the constituents of bleaching powder. This is constituents of bleaching powder, and this, my dear student, is also a important compound of calcium. Okay, yes, this is also an important compound of calcium. Bachos, Siberian cat, you guys are so, I don't know how many times do I have to repeat it, bacha. It's deleted from NCERT, not from JEE syllabus. Please open your ears and listen to this. I am tired of telling you all this. I don't know why are you confused. NCERT does not make your JEE question paper. JEE question paper is made by NTA, National Testing Agency. National Testing Agency has not come and told you that we have deleted this chapter. NCERT has deleted this chapter from board syllabus. And in boards, you anyway do not study this chapter because this is from class 11. So please study. Instead of asking this question that, ma'am, is this deleted? Is this deleted? Isn't this deleted? I'm not simply passing my time, I would love to also take a nap, or all this time that I'm spending here to teach you S block, I can definitely go to Goa and, chill a little bit. But I'm not teaching you just for the sake of it, okay? So please study and don't keep asking people, isn't this deleted? Isn't this deleted? So what if it is deleted? No. NTA has not updated the syllabus, bachos. Please don't be confused. Yeah, I'm only telling for your good thing. Once you sit in the exam hall and then suddenly when S block questions you see, right, you will fall down unconscious on the floor. NTA has not come up with any news whatsoever. NEET question paper is made by NMC. NEET question paper is made by an organization called NMC, NMC has recently told you that yes, some chapters are deleted, some chapters are not deleted. But NTA, National Testing Agency, who make the JEE question paper, they have till date not updated us about the syllabus. So we have to study. Please do not be in this dilemma that ma'am, should we study, should we not, should we study, should we not. You have to study. That's the end story. Okay, you have to study. All right, everybody, I think this is it. This is it. Is there anything else that we have to read? Plaster of Paris. Yes, we have to read about plaster of Paris, bachos. Okay, I think calcium carbonate also, you know how to add, how to make it, right? The addition of, you know how to do calcium carbonate also, we have read about it, that is there. Now let's start talking about plaster of Paris. Okay, so you all know that plaster of Paris or gypsum, plaster of Paris, we are going to talk about plaster of Paris, but before that, everybody, you have to understand that there are two compounds that here we have to study about. First of all, the first one is CaSO4.2H2O. Okay, what is this? This is called as gypsum. This is called as gypsum. When you heat gypsum at 393 Kelvin, what happens is 1.5 water molecule, 1.5 water crystallization flies away, and that is when you get calcium sulfate hemihydrate, that is half H2O. This is called as POP, that is plaster of Paris. Okay, this is called as plaster of Paris. All right, but if you heat this above 393 Kelvin, then you will get only calcium sulfate. What will you get? You will be getting only calcium sulfate. All right, everybody. Yes, and finally we come to something called as Portland cement, and everybody please pay attention. Portland cement has come in the previous year question paper as well. Portland cement, the ingredients of Portland cement, what are the things that are present in the Portland cement, what is how do you get good quality Portland cement, all of these questions have come in the previous year question paper. So please pay attention, everybody. What are we reading about? We are reading about Portland cement. Okay, in Portland cement, what are the ingredients of Portland cement? Very easy. You write it as dicalcium silicate. Yes. Then you have tricalcium silicate, and you have tricalcium aluminate. What do you have? Tricalcium aluminate. All right, bachos. Yes, tricalcium aluminate. This is what you get. Now, in this, okay, in this you have CaO, SiO2. All right. Then you have Al2O3, CS, AIM. CS, computer science should be your aim, that is MgO. Then what happens? Life, fine SO2 can be what? Calcium computer science aim fees. Okay. All right, let's talk about that. So CaO will be about 50 to 60%. Okay, CaO will be about 50 to 60%. SiO2 will be about 20 to 25%, everybody. Al2O3 will be about 5 to 10%, everyone. Okay. Then you have MgO will be about 2 to 3%, everyone. All right. Then you will have कुछ नहीं समझ आ रहा है. Why are you not able to understand? Please tell me. बताओ क्यों नहीं समझ आ रहा? बताओ क्यों नहीं समझ आ रहा है? मैंने बोला there is something called as Portland cement. Cement समझते हो ना भाई? Haven't you ever made your house? Have you seen how buildings are constructed? Cement is used. In cement, these are the ingredients. In cement, you will have dicalcium silicate, tricalcium aluminate, tricalcium silicate. Ingredients of cement. Cement में होना जरूरी है. ठीक है? Understood? Now, in the cement, you will also have calcium oxide, silicon dioxide, Al2O3, magnesium oxide, Fe2O3, SO2. These are also present in the Portland cement. All right. Fe2O3 will also be about 2 to 3% and SO2 will be 1 to 2%. These are the percentage of oxides that are present in the cement. इतना नहीं समझ आ रहा है क्या? है? Paglu. Anyway, now SiO2 and Al2O3 is supposed to be present about 2.5 to 4. The ratio of 2.5 to 4 ratio of SiO2 and Al2O3 should be present, okay, should be present for good quality cement, okay, for good quality cement, okay, good quality cement. Am I clear, everybody? And rest of the things, that is calcium oxide, magnesium oxide, Fe2O3 and SO2, these should be around 2. The ratio of these ingredients should be around 2. Am I clear? Is this clear, everybody? Now you also have to learn a little bit about the preparation. How do you prepare it? How do you prepare it? How do you prepare it? You prepare it by taking limestone. Okay, you prepare it by taking limestone. Plus, what do you do is you add clay to it, and then what do? You get cement clinker. Okay, what do you get? You get cement clinker. Okay, you get cement clinker. In that cement clinker, when you add certain amount of, you add a certain amount of gypsum. Okay, certain amount of gypsum, that is CaSO4.2H2O. Then what do you get? You get cement. Okay, whew, and that's it. This is the end of your. This is the end of your S block elements. Okay, this is the end of your S block elements. But am I letting you go just like this? No. Let's do 2 questions, everybody. Let's do 2 to 3 questions. Everything is done. All of these notes are there. I'll be sending you the notes in the Telegram channel, everybody. Do join the Telegram channel, and then I will be sending you the notes. So chalo, let's answer the questions, everybody. Tell me now. The element having the greatest difference between its first and second ionization energy is obviously, it will be from group 1, isn't it? It will have to be from group 1, everybody. Yes. And now you tell me something that has a little small size also. It cannot be too big in size, because if it is too big in size, then what will happen? Ionization energy will always be smaller when it is bigger in size. So that means that calcium, no. Sc is scandium. Why are we talking about scandium here? No. Barium could be, but however, barium will have ionization energy 1 and ionization energy 2, both of them will be a little lesser than group 1. So group 1 we only have potassium, and potassium is the correct answer. Very good, Karthik. Very good. Yes, potassium is the correct answer. Well done. Very good. Cute Dino, and very good, Purnima. Very good. Next question, everybody. Which one of the following is an oxide? Guys, we already know that potassium does not form oxide. Potassium forms what? This forms superoxide, isn't it? This forms superoxide. And we also know that barium also forms, barium does form oxide, but however, it's in the end part. And this O2 does not look like a oxide, does it? CS is cesium. Cesium also will form what? Superoxide. This will also form superoxide. And barium being at the end will also form superoxide. It's only SiO2 which is an oxide. SiO2, silicon dioxide. This is an oxide, everybody. See, these kind of questions may be asked to you in the JEE mains exam. Are you guys getting it? Yes, everybody? And with this note, we are done with today's chapter. Yes, we are done with the whole of S block, everybody. I don't think anything is left. I have pretty much taught you everything. Do check it out with the NCRT. Do just correlate it with NCRT once. And if there is anything that you find, do let me know in the comment section if I have left any topic. If you let me know, I will be able to make another video regarding that and I will upload it. Okay. With this note, Dhanyavadagalu. I will see you very soon. That is at around 8 o'clock. 8 o'clock I will see you. I will try to see you at 8 o'clock because I will be doing P block JEE advanced questions. So be there. Don't miss it. And lots of love. All the very best. I'll see you very soon. Stay tuned to the channel and don't forget to subscribe because we will be sending you a lot of notes, everybody. The exam is coming up very, very soon. Not much time is there. Okay. All right, not much time is there. So please stay here, stay tuned and keep coming for the classes so that we can together ace our JEE exam. Okay. Hey, no, I can't wait, Baba. I am very hungry. I want to go and eat and then I have to again take a class at around 8 o'clock. Now, need a little breather, please. Need a little breather. Okay. I'll see you. Tara, bye-bye. Tara, bye-bye. See you guys. Also sending you the notes, everybody. Chalo, I'll send you the notes right away, everyone. Let me send you the notes right away. I understand I'll miss you too, but I'll see you. Okay. I will see you, everybody. Here we go, guys. Sending it to Vedantu JEE English channel right away. I need you all to join the Telegram channel. See, check it out here. See, 53% is already completed. 60%, 70%, it will go right now. You guys quickly go and join the Telegram channel so that you get the handwritten PDF, everybody. Whatever I have taught you in the PDF, everything is there in that PDF. So learn it and all the very best. Practice the question.